talk to you guys. So for those that don't know me, I am Dr. Jerry Smith. I have a background in AI, cognitive psychology, that sort of stuff. I've spent a lot of years in this particular space. The more interesting thing sometimes is the fact that I used to fly jets off of carriers and ran nuclear reactors on submarines and did some other interesting work for the Navy. And then out of there, I continued my career in the area of computer science and artificial intelligence. Spent a lot of time in this space causality that we're going to talk about today. All right, it is 9:05. We've got a quorum available to us today. So I'll kick this thing off officially. Welcome to AI in a Day. This is a Microsoft and AgileThought collaboration event. This is the first of many, right? I am one of your two hosts, Dr. Jerry Smith. Let's just see if I can make my presentations move across the screen like I want. I'm one of your two hosts, Dr. Jerry Smith. My other partner in crime here is Arni Steingrimsson, and he will be talking to you in just a little bit. He's one of our, he's our principal data scientist in our group here. Between the both of us, today our intent is to have fun. And as I had mentioned before, this conversation is being recorded out there. So now my legal team can go off and do their other things. But for us, we hope to make this an enjoyable day for you. We have about 3 hours of time with you. As I woke up this morning and did some posting on LinkedIn, it reminded me of a couple things, my pre-presentation jitters. This is a live event. Anything can happen. And I was reminded what Elon Musk once said when Starship 1 was on the launch pad. He goes, "We think it's going to blow up even before we light the engines." But as long as we get some science out of this, and we can learn from the event, this is going to be a success. So I am here with all my COVID. I am recovering from COVID. I am here with our team, and I'm looking forward to spending time today with you. All right, so what is our agenda today? Our agenda first is going to be to set up a lab, get that going, because that's going to take some time in the background to do. We're going to then move into artificial intelligence in perspective. This is where you get a chance to hear me speak for around 30 minutes, right? And my goal in this is to hopefully change your perspective on what AI is, and most importantly, what it isn't. And the outcome of that session is going to be to instill in you this sense that as AI practitioners, our goal is to change the world, not just observe it. Our goal is to change the world and not observe it. And the way we're going to do that is we're going to walk you through Causal AI in this great Microsoft ecosystem that we have, right? So we're going to walk you through a breast cancer example right away. And at the end of that, you're going to see hopefully some amazing things that we'll talk about. Then we're actually going to get your fingers dirty in this if you choose to, right? You don't have to, but if you choose to, we're going to take those files that you upload, the environment you created, and we're actually going to walk through a causality lab around student grades. And we'll talk about that when we get there. After that, we're going to take a break, right? Because you probably by that time either determined that you need to get a restraining order against me, or you need to recharge your battery so that we can get into the next phase, which is machine learning. Now that we've figured out what's causal, we want to actually build digital surrogates, right? Which are causal-based predictive models. And we'll talk more about that. We're going to do that for 30 minutes, take another break coming back. We'll wrap up the discussion around optimization. It'll be just a discussion, and then we'll close it out with some call to action stuff, right, in that particular space. So this is our agenda for today. This is normally what I would say is if you're having difficulty or if you have any questions, please add it to the text file, but I don't think we're going to have access to that today, and I apologize for that. I don't know if the team has a workaround for that at any time. Please let me know. I'm looking at messages just to see if there's any issues. If you have any issues in this particular space, if you send them to marketing@agilethought.com, marketing@agilethought, we'll try to do that real time as best we can. You know, if you just put in the header, AI in a day, marketing@agilethought.com, they'll take that and they'll text it over to me, and we'll see if I can work with it. Okay. With that said, we need to get your labs going here, right? And this is going to be a parallel process. And Arni's going to take over the presentation in a second, but this is the basic workflow that you're going to see here. So as you're looking on the screen, you're going to see that we're going to send you to this particular event. You're going to register now. You're going to create an activation code. You're going to launch it. You're going to get some environmental details. You're going to grab your username and password, go to the Microsoft portal, click on machine learning, launch the studio, kick up your cluster, and upload the files. We think that's about 10 minutes here. So Arni, if you'll take that over right now,
Yep.
we can pass the first test and get your screen replacing mine and your face replacing mine. And then I'll come back right after that.
All right. Again, let me go ahead.
By the way, Arni, we didn't pass the first test, right? So there we go. Now the first test is done.
All right. So hello, everyone. So like Dr. Jerry said, and by the way, thank you, Dr. Jerry, for the introduction. So the first step was to go and click on the link that is already posted, the bit.ly link. That will get to a page where you sign up and you register with all your information. As soon as that is done, you hit launch the lab, and then it should bring you to a page like this. It will have your virtual machine here on the left, and then what we're interested in is to grab the username and password. So let's go ahead and open up a new tab here in your browser. And what we're going to do is to type in portal.azure.com. So for those of you that already have or are working in Azure, you're going to be going to your regular content, or sorry, your regular username. But what you want to do is to switch. So sign in with a different account. So you hit that, and then you log in with your new information that are given to you here from the Clouds Lab. So this is the only thing we need from the lab. So in the background, they have already spun up environment for you in Azure. So this is the only information we will need from that to do our lab. So once we get logged in and we get to this Azure portal page, the thing that we want to do next is to go hit the all resources. And this is going to allow us to see everything that the lab has set us up for. So we'll have a whole bunch of content here, a whole bunch of services, I should say. What we're interested in is to hit the Azure ML. So you can also see it here under the type machine learning. And we're going to click on that. And then what we're going to then do is to click the Launch Studio. So this is what Azure called the Azure ML Studio. And once you hit that, you will get to this main page here. So you get to this main page here. So this is where the machine learning people and the data scientists live within Azure. So this is an environment where you can control, you can have compute resources, you can bring in models, experiments, and then what we're going to go through is using notebooks and the designer. But to get started in the setting up, let's go to the compute section here. And we're going to, so we already have pre-allocated the compute cluster, which is used for AutoML and then for the designer. But what we need to do is to set up compute instance, which is going to run our notebooks in the background. So let's go ahead and do that. And we can select any of these. Probably want to pick the one, the DS12 version 2, because it has more memory. So we hit next, give it a good name. And then we click, and by the way, there's no spacing or anything like that, just one continuous string, and then hit create. So while we're waiting on this to load up, the next step we need to do is to upload our notebooks that we guys sent you. So last night and this morning you should have and also in the chat, you should see document that has, or a folder, zip folder. You need to unzip that folder on your computer, And then the next step would be to hit the upload folder, and then you would go and upload that folder and put it in here. So once you've hit the upload, you should see a content with data sets, figures, and then you should have part A and part B. So while you guys are doing this, I will give it back to Dr. Jerry, and then he was going to tell us some more about the next steps, and then we'll then get back to this environment later on. So this is the initial setup we need to do and set up.
All righty, let me see here. All right, so this is again another test for me. There we go, send live. I think I'm back live with you, which is great. All right, so here's where we are right now. Right, you should have gotten for those who want to participate, a couple things. One is you don't have to participate. We always encourage you do, but there's two ways to learn, right? You can listen and take away content in that area, or you can move off and do it on your own. So you should have the link to the portal. You should have registered for it. You've activated the code, you've launched, you've gotten the details, username and password, gone into the portal, started those resources up, and then uploaded your files in that particular space. And those things should all be being kicked off right now. So right now, we are in a position here to move on to some common views around AI. While all that stuff is going, we're going to cover some AI material for you this morning and set the conditions around where we're going to go, right? Am I okay to proceed on, Arni?
Yep.
All right, awesome. All right. So this is that first spot of our conversation where we kind of level set across the table, right? We all come to common terms around what AI is and isn't, and why it's important and not important. And so you've seen, if you've seen one of these slides, you've seen a lot of these slides, right? I talked to these slides a little bit different. And again, my goal is not to make this a PowerPoint presentation, but we got about 30 minutes of this material before we get into the actual lab stuff and demos. Here's the goal of this, is when people look at this and say, well, how important is AI in our world? They say, well, gee, it's a $4 trillion global opportunity. And I think the first thing we recognize is, while Forrester is right, there's a $4 trillion opportunity to bring value in terms of a number of different resources. They're missing the point. The point isn't what's the value to an AgileThought or what's the value to a company that's building software. They're missing the opportunity value that for us to change the lives of the people we impact with AI, right? It's those people in the healthcare areas where they were helping, overcome suicides through AI or COVID through AI. It's in the banking and financial areas to help people recover their financial assets through AI. It's in the area of transportation, making sure that the trucks and services actually get to where they want to go on time with the least amount of spoilage. That value, the economic value of AI in that space is 100-fold this, because that's our society, right? And as you take a look at the traditional means of it, they're just counting for things like decision automation and smart products and stuff like that. It's an important number. If you're in the business of building these products, it's a healthy industry. But when you and I look at AI and we start to say, how are we applying it? We should always be thinking about our customers. How are we going to help them change their world rather than just observe it, right? And those numbers are not accounted for here, right? That's an important thing. We take a look at what companies are doing next in this world of AI itself. We're seeing how deep neural networks are affecting data scientists. We're going to talk about some of that today. We see how modern analytic platforms like Power BI and stuff like that are becoming fully integrated with natural languages. We're seeing companies dedicate workers to monitoring feature activities that are coming from neural systems, right? If you're a police officer walking on a street and you have a body cam, you now have people in the background making sure that the algorithms for facial recognitions that are often authorized are not biased, right? And that's happening in real time. There are a number of companies in that area. We have data scientists, right? Spending more time with just automating tasks for people, right? New revenue coming from very specific industry. I mentioned two that I'm really jazzed up. I'm a healthcare life sciences kind of guy, pharmaceutical. You know, being able to ensure that people have a healthy life, both physical and mental, is important. Suicides are up, you know, from the COVID. We have a number of different consequences. How is AI helping that, right? That is revenue generated, but more importantly, we have lives saved in that area. And then lastly, in this thing, 1 in 5 workers are engaging in non-routine tasks will rely on AI to do their jobs, right? I mean, just security guards, for example, relying on AI to help them identify threats and stuff like that. So where does all this going? We look at this as AI is an adoption, is a game changer. Now, I pause on this graph, and this is one that a lot of people haven't seen, but here's what I want you to take away from it. You're in one of 3 categories when it comes to building AI systems and using it. You're in the front runner category, which means that you're going to go through that early phases of adoption, figuring out what to do, how to do it. We're going to cover that today. That's where we are, right? And that 5, 10, 15 years from now, you're going to take advantage of that exponential knowledge gained and applying that back to itself, right? That gives you a 100, 120% front runner stats, or you're a close follower, or you're a laggard. Now, why do these numbers look so different? What's the impact? If you're not in a front runner status and trying to work through AI, and you're competing with another company that's using AI in your market against you, the longer you wait, the more exponentially behind you are, right? This isn't like, oh, we just got to double production tomorrow and produce twice as many widgets. The application of knowledge to generate knowledge is a nonlinear event, which can put you out of business if the other side is using it effectively against you. Now, I like that kind of knowledge. Why? Because the more knowledge I apply to my knowledge in AI to help people in healthcare, that means the quicker we get to solutions. But when you have companies out there that are producing products based upon their use of AI to produce that, if you're not in that game, that could be a life-ending event for a company. It's just something to think about. The power of this world is very, very unlike anything that we've ever done in the past. All right, that's enough on those marketing slides. This slide I'm going to hover on for a little bit. There's 2 slides in this morning's discussion that I really want to emphasize with you because it could change the way you look at AI, right? So let me first just deal with this is what we call the cycle of life. And at the bottom, you're going to see we go from this world of data. All right, data is the debris of our human activity, right? It's because of us, not in spite of us. I want you to think about that for just a second. And a lot of us get stuck in this kind of world of you know, talking about what we do. We do data and engineering and analytics and science, machine learning and artificial intelligence. We never really pause for a second to actually ask the question, what do these things really mean, right? So the very first piece that I see folks struggle with is this notion of what is data. So I'm going to just pause here for a second and ask you to sort of close your eyes for a second and think, what is data? Really? I mean, it's ones and zeros. We know that, right? It's stuck in these systems that we spend trillions of dollars building, maintaining, and servicing, right? So we know what the data is. It's this amorphic blob of electrons that are out there, right? In various forms of hexadecimal numbers, et cetera. But data is actually because of our human activity, right? The fact that I went to a website and logged in, data. The fact that I walked out and to the car and turned it on, data. The fact that I flew on an airplane and had my ticket scanned, data. It is because of our activities. And therein lies one of the first keys to us changing the world, is recognizing that in this world of data, it's the debris of our activity, right? And if we can decode that debris of our activity and reverse engineer it back through the applications that created it, back through the people, then we therein lie have our first secret to changing the world. So data is important. We have to engineer that data. We have to bring it in through various systems. We won't talk about this a lot today in the Microsoft world, but Microsoft has some great ecosystems for bringing that data in. We'll touch on a little bit. We engineer a machine learning record, and then we move into the second phase of analytics and data sciences. So I'm going to do this first definitional stuff for data, machine learning, and artificial intelligence right now. Data science, this step 2, 3, and 4. Data science is making sense out of data. It's creating those models. What's the average intelligence in the United States? We take 320 million people, we line up their columns, we add up we sum up all the IQs, we divide by n, right? We know that's a normally distributed number. So data science is the science of making models out of data, right? The next thing is, what's machine learning? Well, machine learning is simple in AgileThought land. Machine learning is all about understanding how that data changes over time and space. It's about predicting tomorrow. Yes, there's a lot of other characteristics of machine learning, but if you're a practitioner who wants to change tomorrow, the way you think of machine learning is, now that I got models, I need to understand how they change in time, this week, this month, this year, and space, left coast, right coast, people that are older, people that are younger, right? How does it fundamentally change over time? How can we predict tomorrow's data based upon the past observations of it? And then lastly, artificial intelligence is simple then. Artificial intelligence is, and it's also the most important thing, is all about making better decisions. When you get hired by a company, yes, they want to know, can you code? Yes, they want to know if you know architectures. Yes, they want to know if you know schema and database, and can you do X, Y, and Z things. The most important issue that they have is, do you fit in our culture, and can you help us make better decisions? So artificial intelligence is about augmenting that process. Now that I can predict tomorrow, now that I know that my IQ is either going to go down or up, or the students are going to be healthy or not healthy, or that education is good or bad, our goal is to say, how do we change that? How do we change the conditions? And that's why we get into this causal-based predicting, which we're going to actually do today with you, right? We take that data we have, we then sit down and we say, of all that data, let's determine the causal model and get rid of the correlation stuff. Not that there's anything wrong with correlation, but with causal, you can change the world, not observe it, right? So we build that, we get that causal data. From there, we move into the world of digital surrogates. This is the when and where. This is the prediction. What inputs do we take for our models? The causal models, right? We now create a predictor that says, given these inputs, I can now predict that. By the way, given these inputs, which are causal, I know if I change those inputs because they're causal, I can affect an outcome. You now have a superpower. That's an amazing superpower to think about, right? In that particular space. Once we have that digital model, what do? We optimize it, right? That's all about AI, making better decisions, right? That's at step 4. We're not going to do that today, but we're going to talk about that today at the very end of this section. So what do? We take that big box, all those causal inputs, your output, and we search that space to maximize the function you want. Less suicides, short amount of time, least amount of cost, right? You want to be able to go in there and get better health, short amount of time, least amount of cost, right? You're maximizing the outputs as a function of that. What do you do now with that? Well, we already said that the data we're looking at is causal. Those inputs are causal. So we know if we change those, we'll change the world. So we sit down with our marketing, sales, and operations folks, and we say now, how do we take this input from the level it was before to the level we need it to be? And they put in place sales programs and marketing programs and operational programs. If you're a doctor, you put in place new healthcare programs. If you're an insurer, you put in place new management programs for your employees, for your constituents. Do outreach programs that say, hey, we think your cholesterol is going to go up. We want you to do X, Y, and Z. That is then step 5. We implement those changes in the field. And what do then? We sit back and we watch what happens. Why? Because human behavior changes, and when human behavior changes, what do? We get more data, more digital debris, and then we wash, rinse, and repeat this process. And this process over time will change your business, will change your constituents and your clients, and will change the world. That's the power of this, and that's what we're going to walk through today. We're going to walk through the first couple steps, the causal-based step. We're going to spend a lot of time in there, and the digital-based step. So that's that particular, this is the first slide I want you to walk through. Think of data as the debris. Think of engineering it in a way, which we're going to talk about. Think of the data science as creating models. First model we're going to create is a causal understanding. Then we're going to do a predictive, and then we're going to eventually get into optimizations we won't cover today. Okay, we're going to move on with an overview of our environment today. I think I have about another 15 or so minutes before we move into an overview of the actual process. This is this requires a little explanation. So if you're typing on your email or drinking some coffee or having a conversation with a colleague, this is one that you probably it's worth just kind of staring at for a second, because it is multidimensional. Over the last 20 years or so, I've been fortunate to have to work with a number of folks that have helped us understand the characteristics of successful data science, machine learning, and AI capabilities. And you see the results of that here, right? And what you see is from a left to right, you see data on the very far left, either your enterprise data about the value in your company, your IT data about how things interact with your IT systems, or open source data. By the way, we're going to be spending time today with UCI, open source information. You see how in that data these capabilities, right? Every box is a set of capabilities. And these capabilities are designed to do one thing and one thing only, is to remind us as practitioners, what do we need to do to get from data on the left to insights on the right? What this says is, if you go through this process and contemplate how these things interact, you stand a pretty good chance of succeeding. More importantly, what we try to do is keep people off the failure path, right? By missing something. Oh, you know what? Elon Musk example, the Starship 1, you know, we forgot to fuel a rocket. No wonder it didn't work, right? That sort of stuff, right? So these ideas is to remind us what we need to do in a staged way. So from left to right, these are the capabilities we have. So we're going to do some text harvesting today with the CSV files. We're going to bring those in the lower bottom here, doing some causality analysis. We're going to do some descriptive and classification work. We're going to actually build a decision tree out of that. And then we're going to move that in and we're going to see if we can learn something from that. And this is how they all connect together. Now, how are we doing that? On the far right-hand side, you'll see the ecosystems. Today, first and foremost, we're doing that in a very, very powerful environment, right? Microsoft Azure ML. Now, I'm a practicing data scientist. I will tell you that the Microsoft team can come on here and tell you 18 different ways that this system is super important, super powerful. I'm going to go through a few of those with you today from a data scientist point of view, because here's the thing I like to do. I like to never have to worry about my ecosystem. My job is to worry about my problem. If I'm fussing around, you almost heard me say a bad word. If I'm fussing around with the ecosystem, I'm not worried about people committing suicide. If I'm fussing around with the ecosystem, I'm not focused on why they're not buying my product. If I'm fussing around with the ecosystem, somebody is stealing money from my bank, right? And that's the thing that Microsoft Azure gives a guy like me and a guy like Arni, is our ability to do this work in an extremely scalable and powerful way. And it gets us, as you're going to see, it's going to get us to some interesting conversations that we can have with real business people. So that's number one. Number two is we're going to be using something called CausalNext. We have two ecosystems today. This is CausalNext is an open source causality environment. A little plug here. If you're not looking at causality by the end of this, by the end of your session with me today, you should reach out to me and go, I don't get it. And so I can figure out what messages I'm missing here, because causality, the book of why, go Amazon it, right? The book of why is the most important thing that anybody listening to this, any of our attendees today can walk out of this, is trying to understand why these things are happening before we go off and build when and where they're going to happen, and then before we build how we're going to solve them. That causal box is the single most important box that you can do. And we do that today with CausalNext, but we also have partners like Compellon, and we also have partners like with Bayesian Labs, right? Those are higher end systems, just not something we can do within the scale of today. And by the way, I want to let you go off and do causality work without having to bring on third-party people. This is an open source solution, right? And then finally, we're going to do this in Python, and we're going to do this in the lab environment. We go to the far left-hand side, you'll see that we're principally doing data sciences and data engineering work here. And then lastly, it's level 4 activities, which means we got some everybody on this call doing this is going to have to be fairly sophisticated. We like this single page because on one page, it's basically the circle, the things that we want to do, see if we can connect lines, have conversation about it, figure out what resources we need, what tools are we're going to have to bring to the table, and what risk level of analysis are we going to have. So the two slides I want you to walk away with were that first one on the cycle of life, the 6 phases, and really thinking about that. And the second one is this slide here as we're moving forward. All right, a little side trip, because I do want to let you know what we're doing in the Microsoft world today. I have about a few minutes left before we actually get into the demo. And that's the machine learning on Azure, right? I mentioned, I am not a Microsoft salesperson. I will tell you this, I have sold more Microsoft because I just sit down and use it in ways that make my life easier, right? And so these are the areas, when we look at our ecosystem in here, we ask the question, what do we need to bring to the table to solve the problem? Now, the very top level, cognitive services, we're not doing in this one. In the March event, we're going to touch on cognitive services, because this series, by the way, the one in February, the one in March, and April, et cetera, they all build on each other. These aren't designed to one replace the other. If you choose to come back and have the conversation with us, we're going to build on some of the material, we're going to add to it. Our goal over time is to change the world. It started today with you guys. And so in that space, we're going to need to get into visioning and speech and language and search, right? We're not doing that today, right? That will be probably the March timeframe. However, we are going to be employing the Jupyter tool sets that we have in there, which for those who don't know, that's the lingua franca of documents, whether it's an Azure notebook or a Jupyter notebook, Jupyter Labs. That's our ability to actually begin to get our fingers dirty, hands-on. You're going to do that work today. We're also going to use some frameworks in here, right? Scikit-learn is one of the common ones. We tap into that. At some point in the future, you could be doing PyTorch for a lot of your interesting neural stuff. You can be doing TensorFlow. Who hasn't heard of TensorFlow, right? I mean, if you want to be tensor-based and stuff like that, things like that, or you can go open with Onyx, right? You can bring in a lot of different tools in that. We're only today going to focus on that, but when we're planning projects out, we're looking at that level. And then productive services, right? We're definitely tying into machine learning today. We're going to get into that ecosystem. You're going to see Arni mastermind that kind of thing. And then finally, we're going to do this in a CPU-based environment. So we're not going to use GPUs today or floating point graphical units or anything else like that, right? From our machine learning environment, we're touching most of the areas today. And by the way, our goal isn't to sit there and say, okay, let's open up a notebook and administrate and stuff like that. We're doing the work again, but recognize what our ecosystem is doing now. We're just doing the work in Notebook. We're going to do drag and drop when we get into the wizard stuff in there. We're going to bring in data sets, right? You've already uploaded it. Now what do we do with it? We got to train on it, right? You're going to see all that, right? It's just going to work. Knock on wood. This is when I usually say that and everything turns off on me, right? And we're going to do this in a cloud-based distributed CPU environment. If you need additional power, we can go graphics. If we need additional of that, we do function points, right? And if we actually need to do some really heavy work, which we won't be doing today, we can push things out to the edge, right? Which is really, really powerful, right? So this is the last time you'll hear me talking about this, because after this, we're just going to do it, right? And in this case, here's an example, by the way, of the designer. We're going to get into this. This is my favorite place, especially when I'm thinking through problems. As a cognitive psychologist, human beings are very visual. It's hard to innovate in words in notebooks, but to innovate in a creative space like Azure with this visual interface, it's just amazing. And you're going to see that in the second part of today's demonstration with where you're going to get your hands dirty on that. Okay. All right. So here's where we are. We got your labs up and going. They should have been baked by now. We covered a little bit on two really important slides, right? The first slide was around getting our thoughts around what is data science, machine learning, and AI. Data science making sense out of data. Machine learning is predicting how those models change over time and space, and AI making better decisions, optimizing those models based upon your constraints, right? We talked a bit about the data science Rubicon, the capabilities model, taking data to insights through all those capabilities. I think last count there's 63 on there, right? And how we stage gate them together against both the infrastructure we have, the resources we need, and also the complexity of the problems that we're going to have there in terms of the roles that we have. That now sets our stage for our first walkthrough that we're going to do today. All right, and by the way, I'm going to cover this slide, Arni, and are you ready to go? When I'm ready to turn it back over to you?
Yep.
All right, so here's the first spot that we're going to start changing the world. You're going to hear me say change the world a lot and a lot and a lot. This, for those who are looking at, this is my favorite. Now my marketing team is like, oh my goodness gracious, Jerry's gone off the rail again. Back about 10 years ago, when I was doing data science a lot more with my hands than I am today, my wife got me this crystal ball. She heard me talk enough times about helping people predict tomorrow, whether crops are going to rise or not rise, people are going to get sick or not. She says, you need this. This really represents, as a machine learning specialist, somebody whose job it is to take all that data and help people understand how it's going to change tomorrow, next week, next month, this is you. And I've never let this go. When I talk to customers, I say my first job is to make this ball transparent, is to get you in this space. So we're going to do that here. My second job then is with this crystal ball, not just to leave you hanging, actually is to then optimize what we know about tomorrow to get you in a better place. So we're going to start that today with breast cancer, malignancy. This is, for all of us data scientists out there that are complaining, how many times have we often heard each other say, we don't have enough data? We can't do this because we don't have enough data. I need more data. We've told people this time and time again. If you don't know UCI, you need to live on UCI, right? As a practitioner, there isn't a problem in the world that I can't begin to solve by not starting with UCI data. It's not perfect, but it gets you in the right spot, and it gives you practical information. And also, what does it else? It gives you access to the people whose insights that you can tap into later on. So we're going to start in two areas. The first one's going to be breast cancer malignancy. This is a common problem in the United States. This data set actually goes back to 1995. And what our goal here is today is when they take biopsies of cancer in the body, they'll get a pathologist to take a look at that and do some measurements. They'll measure the height and the width and the density of it, and then they'll pass judgment. Is this malignant or not malignant? Our goal today, so that's the state of the practice, and we're really, really good at that today. We've augmented this. We've automated this quite a bit in the years since 1995. A lot of algorithms that have come out. We can actually do this work very successfully. But here's the thing: up until the last couple months, that the world really hasn't looked at, and that is, well, that's interesting. What's causal? What are the causal relationships between all the parameters that I'm looking at and the actual, is this malignant or not? Just pause and think about that for a second. What are the causal connections between all that data, which we're going to review in just a second here, and the outcome? So what we're going to get to is this graph. So this is an overview of where we're going to get in this demo session, and then we're going to build a predictor on this that says this, of all the parameters, this is what drives the other parameters. And all those parameters, if you start to cruise down, you look through here and you see disease or not disease, right? You'll be able to understand the relationship around all of these areas, right? This is our first causal model that we're going to get to, and then we're going to do a predictor, right? That is, and we're not going to talk about the Microsoft environment. We're going to just use it. We're not going to talk about the data elements. We're going to talk about the meaning of the data elements. We're going to use them. And then we're going to get in and actually do this stuff. And Arni's going to walk you through what we're doing. This is not a hands-on for you. This is a chance for you to see the steps that we do. We'll have the discussion in just a second, and then we'll move on with the wizard demo. And then we're going to actually then go in and let you do this your own with a different demo. All right, Arni, do you want to take it over?
Yes, sir.
Or maybe not. Maybe you're like, oh man, I got to run away from this one. This is way too hard.
Let me go ahead and get the content on there and send it live.
I think they actually want to see your wonderful Icelandic chiseled face versus mine.
There you go. All right. So where we left up last time was that we were uploading files, and then we had already set up our compute. So we have now our compute instance running, and this will allow us to run Jupyter Lab and regular Jupyter, RStudio, and Terminal. So let's go ahead and jump back into our notebooks here. And we can here in this drop-down menu, pick the Jupyter you want to view it in. So our standard Jupyter or Jupyter Lab, or you can just view it in our Microsoft environment. I personally prefer, and I kind of live in the Jupyter Lab, gives me more flexibility, but it's all running in Azure. So first thing we do is sign the waivers, hit continue. We sign in again with our credentials we got from the lab, and then give it a minute or two. And now it's like we're living just on our laptop. with our Jupyter Lab. So, but before we go through the demo, I want to take one step while we're doing the demo. I'm going to kick off some installations. So Microsoft already has the Azure ML preloaded with a lot of most common libraries, but there are some unique ones. And first one we're going to kick off is to do the Causal AI, and we will use the Causal AI for all of causal analysis, and then we use PyE charts for our visualization. But we'll get back to those and talk more about them. But let's just go ahead and launch them while we go through the demo. So again, this is a Jupyter Lab. You select the cell you're working in, and then you can do Shift and Enter, and then we'll kick it off. So while this is running, we'll go back to the demo, and we can launch that. Another thing we can do is we can press Control B, and then I'll hide them. We'll give us a bigger landscape here. So again, yeah, welcome to this lab. So this is our first demo we're going to do, Dr. Jerry and I.
Arni, just for folks to set the stage between the two, you're going to, on this one here, your goal is just to walk through a process in the breast cancer area, just so they can get a flavor of what's going on. They don't actually have to have their fingers on this keyboard now.
Right,
Once we're done with this, we're going to go into the Causality hands-on one, where we actually want them to bring up their keyboards and work this process.
Exactly, yeah. Just while this is baking here, we can't really do anything for the demo. So in the meantime, yeah, just look at my screen and I'll walk you through a short demo of how we can, how you guys, it's a precursor into what you guys are doing. So the first step we do is to import some libraries. So again, we're installing now the Causal AI, we're installing the PyE charts, but then once they're installed, we will have to use them, so we import them.
Right. And the nice thing about this is all open source library. Yep. So there's nothing proprietary. You can go online. We can provide access to where we find things like Causal AI and stuff like that.
Exactly.
Yeah.
Then the next step is that we do some settings. One of the things that you'll learn if you're new to Jupyter Notebook is that they have, by default, they don't give you, at least when you're viewing your tables, they only give you a limited view. I think it's 25 columns, but so it's useful if you have a large data set or machine learning record, which is showing one outcome per row. So then you have multiple columns. So that's why you want to increase this so you can view all the columns in here in the Jupyter Notebook. So, and then we also want to set up or load our JavaScript. So most of the visualization is done with JavaScript, and this is to support our imported visualization, and which relies on JavaScript. Then we declare some variables. So we're going to initialize or declare the data frame here. So we put the data into this data frame, and we just declare it with empty. So the next step would be we run this widget. So it's not visual, but you will see it in our lab here. But the main thing is that you're going to be viewing some drop-down menu where you can select between data sets. But in our case, we're just looking at a breast cancer data set. So when we start looking at the data, the first thing we need to do is we need to clear out the ID column. So let me go further down and show you. Here's the data we have, but it has a ID column in here that is just an ID for a patient. It has no reference to our data set other than it's just some random ID that is given. It could be based on when he showed up, could be based on when the biopsy was, but it's irrelevant to or has no causal relationship to the cancer.
So, and let's pause for a second here. Right? This is one of the first places where a lot of data scientists get hung up when they're venturing into causality, right? You will see in your lab, we're actually going to have a strong conversation about what columns don't we want to include in the analysis, right? You will actually oftentimes get guidance from your general counsel in your company to say, you can't include sex or race or religion. You can't include any of those factors in the causal analysis, right? And we're going to have a conversation on the pros and cons of that. But this is one of the first steps as a causality specialist in this data science phase that we're doing in, that we need to have conversations with our business partner around items. Obviously, ID has probably 0% chance of having a causal relationship, although there's been arguments on that in the past. So, but as we begin to remove fields in here, we may tamper with the causality structure that you're going to get to in just a little bit of time. So do not undervalue this step in taking a small pause, picking up the virtual bat phone, having a conversation with your chief medical officer, your chief compliance officer, your chief product officer, the head of IT, and saying, of all this data we have in here, are there sensitive fields that we need to consider? Race, sex, religion, etc. Are there fields that we want to be more inclusive on in that particular area for various reasons that we want to have, so that we initially can start our focus around the causal area. This is often just a click and a go to the next line for most people. But this is where you stop and you begin to think that first question. Let's go ahead and continue on.
So yeah, thanks, Dr. Jerry. Then we also have a step here of doing the data engineering. So in a lot of our data sets, we'll have a lot of categorical columns, which will contain text or some other values. And one of the first steps when you work with data and machine learning is that, or data science, is that you will have to convert all your columns into continuous variable or numerical values. But in our case, we only had one categorical variable, which was the diagnosis, I believe. And so when you run through this step here, the pre-processing step, it will just convert all the columns into numeric. And so as you can see, we have quite a lot of columns in here.
Let's look at that real quick.
Yeah.
This is so a couple things. Number one is that pre-processing step is very contextualized, right? And I think most of us know how to pre-process data from text to factors and standardizing units of activity, from millions to standardized units, et cetera. But the result that we're getting here for everybody is, this is the next piece, is this is what's called a machine learning record now. Machine learning record, right? And the machine learning record is one row, one instance, one observation, right? So as you begin to think about your data systems out there, right? IT's done, your CIO's done an awesome job, right? Of managing the budget around storing of information. What have you done? You BNC'd the heck out of your data. You normalized it from a 1 to a 2 to a 3, maybe even to a 4, right? Most companies are operating at a level 3, right? You have primary foreign keys, all that wonderful thing, no secondary instances, no repeat values, all that wonderful stuff. That's data, right? That's data storage, right? We do that for a lot of reasons. But as scientists, as engineers, as changing the world people, we have to create a machine learning record, which is an instance of observation. We have to take all that normalized data and denormalize it back into that row, and then pre-process it, right? Now we are ready for insights. So the very first insight is, when you look at this data, can you tell me what the relationships are at this stage, right? And even if we were to go to the next step, which is a descriptive analysis, you're going to find it very difficult to really understand what's going on here, right? And that's why we're going through this process, right? Next one.
Yep. So once we have already converted this now to a machine learning record in all numerical form, we can then start processing or pass this to our causal environment. So we will first need to split our data set into features and then our target. So we put the target, which is the diagnosis column here.
Diagnosis being malignant or non-malignant, right? So we know
correct.
that they supervised learning.
And then, so if the patient was classified as being malignant or benign, those values will be in the Y. And then all the features get passed into the X here. Then we use causal next structure to create a structure diagram based on a classifier. And what this does is that it's going to try to find the structure based on using information theory and find the causal relationship within that within the features. So
let's
go ahead.
Pause on that for a second, right? So now we've used some of the capabilities in Causal Next, right, which is an open source ecosystem, and took the data that we've collected on breast cancer biopsies, identified, said, listen, these are malignant, these are benign, right? So we've done that. Now in here, the way causality works these days, go back to the book of Why, Judea Pearl, and you begin to take a look at the difference between causal and correlation, and causal and what we call do operations. We're not going to talk about that. By the way, if you're interested in just having a causality seminar where we actually get into the nuts and bolts of causality, let us know, right? Because I think people want that, but we've not had an opportunity. Just do that on the sidebar. So the way we do that is with something called mutual information theory, right? That is that in this world of information, in the columns of data we have, that information there's information in it that is mutually bound to other columns, right? And that we can tweeze that out as either something that is causal, we can show that minor variations in one column are driving the columns in the other, or they're just correlations. They just rise and fall with the same tide. That's mutual information theory. So you'll learn that in studying causality. And then what this capability allows us to do is to suck that data in this 3 or 4 lines, and then create this graph that says, here are the causal structures. That is, the things that are driving, X is driving Y, that we can infer from the data that you've given us, right? Back to you.
All right, thank you, Dr. Jerry. So once we load up this classifier or the library, and then we fit our data set. Fit our model to this data set.
And by the way, go back up real quick, because this is one of the things that as you're looking through here, a lot of first-time causality folks get hung up on this alpha and beta characteristic, right? That is part of our learning environment, right? So when you look at the alpha and beta, that's our L1, L2 parameters that we set for learning in there. So by affecting that kind of learning environment in there, we can affect how tuned our model is, and we may overfit it, or how under-tuned it is, and we may underfit it. And this is one of the few areas that we'll have an ability to tweak this causality model to either get a closer fit to the data, closer fit to the truth of that data as now, or loosen it up a bit, right? And looking at the general trends where it may not actually fit very close to this model, but it fits closer to the general population, right? And that's always the blend we get in the L1, L2 parameters in setting our learning.
And so these variables are going to control our generalization, which we can control if the model is underfitted or overfitted. So these parameters is what we can tune to fit our model better.
So open that picture up a little bit, because this is now where we stop in terms of the causality piece, right? And I want you to take a look at this. And if we get down here, see that diagnosis right there in the center, that diagnosis radius there? You're going to find out, it's hard to read on this screen, but you're going to find out that's the malignancy. Is it malignant or not? And so what are we learning, right? Is there a way to blow this up even a little bit bigger on this or not?
Yeah, so we can kind of play some tricks here.
Yeah, do the trick thing.
See if that works better.
That's a little bit better. So look at this now. Now let's again I like to just, these are the pause moments, right? That as data scientists and stuff, we often blow right through. We just came from all that data that we just collected with our pathologists, right? They gave us that data set, you know, of a countless number of observations. It had rows, it had variable after variable, which is everything from the width to the dimensions to the depth to the characteristics of it that we now have. And what we are now looking at is saying the diagnosis is driven by an arrow, right? Any line into something says the thing on the one side drives the thing on the left. X, arrow to Y says X is causing Y. We're seeing that diagnosis is driven by fundamentally two things. One is this variable that the pathologists call texture worse and radius worse. That the disease prediction is fundamentally driven by those two things. Now, on the other hand, if we kind of scroll down a little bit here, we see that things like the worst radius, which is a dimensional characteristics that they compute, is driven by a lot of different things, right? And as a causality specialist, if that's an area you want to get into, you begin to look at this graph and begin to see things like confounders, right? How many of us during the course of our data science career working with statisticians have gotten to the spot where we're trying to identify what are the confounders, right? X causes Y. There may be a Z out there that is both causing X and causing Y. We call that the Z confounder, right? Z causes X, Z influence causes Y, but X is driving Y. We're trying to figure out, we see X and Y, but we don't see Z. And the question becomes is there a confounder that we need to control for in order to do what? Change the world, because our goal is to do what? Our goal is to change X, do X, manipulate X, so that Y changes in a way that we don't, to a better desirable state. And if you have a confounder Z that's sitting out there influencing those, you have a problem. Now, we actually have that problem here, right? We can actually see that problem in a minor way with the diagnosis, right? We can see that worst radius in this particular case is causal by radius SE and worst radius, right? But worst radius actually influences radius SE. And you see that upper right little triangle. These little triangles here are one of the most important conversations to have with our business partners. And again, that goes back to my point that I think that there's probably room for a future conversation on causality, because that's where you go back to your business partners and say, you know what, I know you want to change this outcome by driving it through X, but we're going to have to put programs in place to deconfound, right, to deconfound those intermediate variables Z. This is one of the easiest ways to have that conversation. You now have a causal model that shows the relationships of all the parameters that are collected and computed as it relates to this disease prediction. With this diagram, you can begin to change that world. It's an important place to think about where you are right now. Now, this is just an easy example. We can think about harder and harder suicide, right, and stuff like that we can get into. But with this first example, we have that, right? Just think about that for a little bit. Let that sink in. Let's keep going on with it. So now you have the first piece, causal.
Yep. And then again, we can just to give you an example of if we change the regularization and make it a little bit tighter, you will see that the now our diagnosis is over here, and we have fewer causal pieces tied to it. But with this, I want to go ahead and start creating a prediction model based on the features that we have here. So we will take all the features that are causal to our diagnosis. So, and let's bring out or create a predictive model in our Azure Designer and make a prediction. So again, we'll leave out some other clusters like this one here, which is not causally related. And let's go ahead and dive in. So going back, so right now we're in the Jupyter Lab tab. So let's switch back to our Azure environment, the Azure Machine Learning environment. So one of the first thing we need to do is to, let's go ahead and we have a few samples here, but for my demonstration here, I'm going to go ahead and get the breast cancer data set that we already have, and I'm going to go ahead and upload it. So to work with data set in the designer and also in AutoML, we need to upload those files and turn them into data sets. And Azure does a great job. You can put a monitor on your data set, and they're all being tracked and version controlled and so forth. So let's go ahead and upload this data in here. We'll call it breast cancer. We want to, it's a tabular format, so we want to go with that one. And we're going to throw it into our default storage, which is already created for us. So Azure, when you set up a Azure ML service, it will create workspace for you with blob storage and other tools necessary. So let's go ahead and take our data set, and we're going to go and hit next. It's going to upload it. And give it a second or two. And so the next step is to view the data that you just uploaded, make sure everything is correct, encoding is correct. And what we want to switch here to use headers from the file. So now that we have the headers in here, we can go ahead and clear this out. If you want to take a look at the schema, it does a good job of knowing what schema it is. So we're going to say, okay, hit next and create. So now that we got this data set in here, we're going to go ahead and jump into our designer. So again, we have our clusters here, and then we got a notebook that we are working in. That's our Jupyter Lab here. We got some automated ML, which is can create a prediction model based on where we have a feature set with a target, and then you got a designer where it's a drag and drop and a visually easy way for you to create a prediction model. And in AutoML, you have no way to select the features you want to specifically use. We just kind of set it off and run. But this is really where we want to work in the designer. So let's go ahead and start there. You can also select it on the side here. So you can just click on that. It gives you also some examples that you want to do, but we're going to do create a model from scratch. So the first thing we need to do is to select our compute resource. So we already have that. And so again, that's the compute resource. So the cluster. The compute instance is the one to run our Jupyter notebooks, but the clusters is what we use for the designer. So going back to the designer, our data is already here. Again, let's go select this again because we didn't save it. All right, and now our data set should be here that we just created. And then if you want to view the data, you can visualize it. So this is our data set here again. It gives you a glimpse into the data, so you can click on a column and gives you some descriptive statistics. So it's a quick way to view the data and kind of see the distribution. And then here's our class or our target, the classification column, and it's the only one in categorical format. So the next step that we need to do is to select the columns. So again, we want to find the, so yeah, by the way, you can, so these on the left here is all the functions or all the pieces that you can drag and drop into. So if you don't know where it is, what you're looking for, you can just type in search. And so we want to select a column. So let's go ahead and select columns in the data set. So what we're doing here is that we want to select the causal features, including the target. So we drag from our data, we drag that over to select columns in the data set, and then we hit the edit column, and we start filling out our features that we want to use. So let's go ahead and do that. Let's start with that diagnosis. For example, that's the first one we want to have. We need the texture. We need the texture mean. We need the texture. We need more stuff here. And while I'm doing this, Dr. Jerry, if you want to intervene or tell us more about the data, maybe about the features, for example.
And so Arni's going to accelerate through here because, again, this is our goal here is just to show you quickly an overview, right? Because we want to get your hands dirty in the next lab, and that's where you have a chance to do it. This is the difference between most machine learning activities and a causal AI-based machine learning activities, is that, yeah, you can put all the data variables in here you want, right? You can load 100 variables up there and create a wonderful model that has 100 variables on the input. And then what ends up happening? Well, we had one lab company in the past that wanted us to help predict why their bills, when they would submit it to a payer, were being rejected. If they submitted a series of sequence A, B, and C, it was rejected, but if they did C, B, and A, it was accepted, right? Really weird kind of combinatorial problem. And they said, can you help us with a predictor model so we can figure out which ones to do? Well, in doing that, the answer was yeah, and they included all the variables. But when they tried to change their world, when they tried to manipulate those variables, they found out very quickly that some of the variables that were highlighting the outcome of all this stuff wasn't causal, right? And so they couldn't change their ecosystem by changing those variables. And so by going back to and figuring out what the causal drivers for that problem were, and then including them in the predictor, now what do they have? They can now go back and say, in order to, which is our next phase, our next step, optimize, in order to get a better outcome, if we change these variables this way, now they have control. That's why we spend this time, right? Because our business people now will be in control of their outcomes, not just monitoring them, not just saying tomorrow we're going to get rain, but controlling the weather, right? If you can get to that level. I think this is good enough for now. Why don't we just continue on with the...
Yep, I had 3 more to go here. Hold on.
And again, this is just highlighting how we do it, and but we would definitely want to get into, within this 15-minute period here, get your hands dirty in this area.
So then the next step is to split the data. So what's the purpose of splitting the data is to make sure that the algorithm we have is not going to be overfitted or underfitted. So we need to we're trying to represent the population, and we need to split it up. So we train on one part of it, and then we see the results for our model's performance on that training set, but then we also want to test it on outside something that wasn't trained on that specific data. So in here, we want to split our data set. So we have a whole population. We want to split it 75, 25%. We have multiple ways to split the data. You can randomize, you can stratify. If you have some specific column that you want to make sure you get enough distribution in the training and the test set, you can do that as well. But so for time being, let's just go ahead and split the data now. The next step would be to do add the training of the model. And then we need to add the machine learning algorithm to this. So again, we're using a binary classifier, so 2-class algorithm. So we're trying to predict if it's going to be, if a patient is malignant, or if a tumor is malignant or benign. So that's the goal here. So that's why we pick a 2-class classifier. And for the just simplicity, I'm going to use a boosted decision tree. And boosted decision trees have been known to be very performant, and they don't require a lot of pre-processing. So what I mean by that is that in machine learning, there's different types of algorithms, and some will require you to have the data normalized, They can't be have to be scaled. Like you can't have one features that are in like 0 to 1 and then another in the thousands. And then you have to make sure you have no categorical values or text values. But for decision trees, it does not affect those. So it makes it easy for us to set up a simple prediction models by selecting the boosted decision tree. So again, in the training here, we need to select our target. So let's go ahead and do that. The diagnosis. Then in here, we're just going to leave it as default. And if we had time in the end, I can show you also how to do hyperparameter tuning. We're also missing here is the scoring of the model. And we need to score the models to get, so the data will come in here, it will get the model itself will train, and then we have to score the model. So we're going to throw in 2 of those. And the reason I'm doing that is that I'm going to score both the training set and also the evaluation set. So we're going to, or the test set. So we split it 75% here and then 25% here. And we want to test both. And we have to connect the trained model in here and trained model in here. And then we connect our training portion of it and then our test portion of it. Then eventually we'll end up with go ahead.
This is why I love the visual environment, is you did all the back-end coding stuff. I know it's you know, we'd like to have our fingers go, but now you're doing this with a customer, right? You're doing this with chief medical officer or somebody in marketing and stuff like that. They can follow this. They can actually go, I get what you're doing. So yeah, let's continue this on. Yep.
Yeah, that's why we love the Microsoft Azure ML, the designer, because it makes it feasible for all kinds, business people to follow along and understand and feel comfortable what we're doing. So this is a great tool. So again, the evaluation model is just to take the results from the scored model and just turn it into plot some outputs for us, and then we can kind of compare both outputs. So we're going to compare the results from the classification from our training set with our test set. So this is it for our setup, and then the final step is just to kick it off. So we can just go ahead and create a new experiment. We'll just say it breast cancer, and we'll submit it.
And while it's generating our thing, I'll wrap up this section and we'll just come back and look at the results when it's done. So what did we do? What did we do? What did we do? We took this set of data that our pathologist gave to us and said, listen, can you help me understand, can you help me change the world by looking at the things that I can change that can change the outcome to malignant or non-malignant cells. And so we started off with a very, very complex analysis of the causal relationship between all the data they gave us and that malignancy. And we then sat down with the pathologist and said, here's the causal drivers for this. What is important to you? And that you had that conversation, right? And they came back and said, well, these are the ones that are important. These are the areas that we need to control for. Deeper conversation later on, right? And then from there, we took that output now, and then we went in and we visually created a decision model around good and bad using that same data, and then the elements, the features that were important to the business unit, knowing that they then can turn around after this thing is done and compute and actually change those outputs by looking at how they, if I change these factors in this way, what kind of therapeutics would change these factors in this way? It's an interesting conversation. And again, we're only changing dimensional atrophy, but somebody can say, well, if we can create a therapeutic that reduces the surface area by this much, that would impact whether it's malignant or not. So let's talk about that, because now we know that's a strong causal driver. And now we have this model that they can work with. They're sitting side by side with you doing this. You're no longer sitting in a closet by yourself in the dark doing this. You're sitting with your business unit having real business conversations. Are we done with this yet? Oh, it's still computing?
Yeah, no. So I was thinking we could just, while this is chugging along, let's just switch over to the lab, and then at a good time we can drop back in here and we can show them the results.
So let me do this then. Let me just take the slide back while you're switching over stuff. There we go. This is me, I think. I'm still looking at you though. I failed the test. Share. Me. There we go. I'm going to keep your face up there just because I failed the test again. I don't want to take more time. So here's where we're going. Let me just do this. Share my, do this, do the desktop, do this, do me. There we go. Send live. All right. It's fun working in this new world. There we go. So we just finished up. We're going to come back to that, look at the results. But the idea was just a quick overview. It took longer than we thought, but it was in there. So now what are we going to do? Now this is your chance. So this is where, for those who have stuck with this process, you get a chance to work out some of these problems that we're going to do in this space. And we're going to come back to Arni. What's the problem we're going to work with? Again, let's go back to UCI, right? Great repository. Again, if you are if you're a company and you're trying to find data sets that are in a field where your scientists can work, I have not yet found an instance where we haven't gotten close enough to do some research, do some science. If you're actually in a field that they cover, I've not found an instance in UCI where we haven't used the data there as the basis for us working through our processes, from which then we gather real world data within our ecosystem. It is an amazing repository, right? And then there are hundreds like it in other areas, but you know, Kaggle is one of those that you can go to. So what are we going to do right now? Well, we're going to work with some data back from 2014 in a study that occurred in Portugal with higher education. And the question became, they were looking at is well, Portugal was going through a lot of transitions at the time. Great article on Wikipedia on this study in terms of what really can help their secondary school system prosper more than what it was in the past. And this could be a classic problem, right? We have today. Think about today. Our kids are learning online, kind of like this, right? They don't often get into real school. The question is, are there factors that can influence their grades that we are not considering today? Right? Do we need human contact in order to produce better grades? Is there something about the relationship between the children and their parents that can produce better grades? And that's what this study was designed to look at. So what you see here, you see data from the from this time frame, 649 instances, multivariate data, and here's the kind of data that we have. We have stuff like student sex and their age, and you know, what school were they in? You know, is one of these other two schools that were part of this area? What address were they living? What's the parents' collaboration status? How's that for a sensitive topic, right? Are they living together or apart, right? We start to take a look at it. Did the father have a job? Was the father educated, right? Study time. How much does study time influence your grade? Now, I'm going to sit there and go, you're going to go, duh, my mom and dad, as parents, I'm constantly, you know, telling our kids the more you study, the better you are. Is that true, right? So we have all this data that we've collected here. And then the very bottom results is, what was your grade? Your first period grade, your second period grade, your final grade, right? And so what you're going to do now is you're going to start changing the world again by going through this data and not just producing a model, but by beginning to first answer the question, which you're going to do in this first lab on causality, is to say, what are the causal relationships that these factors, these attributes have to grade structure? And then we're going to talk about that as we go along, right? So that's the first thing. And then the second part is we're going to go build that model now, right? And you're going to have a model. And then the last part we're going to talk about is how do we change the world with that model? So why don't you take it back over, Arni, and then we'll continue on with our work. And then we'll take a quick break after the causality stuff, maybe 5 minutes. Or maybe not. Arni, you're on mute. You want to take it? There you
go. Yep, I'm just getting our content in here. Send.
I am sure these fine folks are tired of listening to my voice.
Yeah. All right, here you go. All right, and so we're back in our Jupyter lab. So again, we're still running our demo here, but right now, let's go and do the lab. So this is our Jupyter lab running in Azure. We finished installing Causal Next. We finished installing our pie charts. And then just to give you some input, if you mess some things up or something is not working, you can always restart the kernel, click it here, and it will restart everything else. These libraries here, they get installed to our cluster. So they will, as long as you have the cluster up and running, these libraries will be installed and stay on there. So running this again you're not going to install it again. It's going to just check that it's there.
And an observation, we could do this in the visual environment too, right? One of our goals here today is to show you the breadth and extent of which two different kind of tool sets give you results, right? Whether you're a textual person or a visual person or both, that's our goal here, right? We can do both.
Yep. So now that we've installed the packages, let's go ahead and, like we did in the demo, and we're going to import the necessary libraries. So again, we select the cell we want to run, and then we hit Shift and Enter. And now we go back into that we want to select our settings for this notebook. So we want to make sure we can view all the data frames and all the columns. We load a JavaScript that we need for our visualization, and we're going to declare our data frame.
And by the way, this is normally, and this is something we got to work on for the next series of events, because I'd love to be able to say to the folks that are actually doing this, how are you doing here? You know, did that work for you? Is anybody having any trouble? And maybe break out and try to solve that problem. I'm assuming that each of you have entered and hit Shift Return in order to execute that, and that's working fine, right? And if you're not having that, if you're having that problem, we'll deal with that at the end, and we'll set up some time with you offline to help you through that. But you should have done those cells, and you should be at this particular spot right now.
Yeah, and as you can see, everything that I've run will have a number, and that's the order that we've been running it. So if I go back and run this one, you'll see that it ran like after the number 6. So you can kind of follow along where we're at. So right now we're gonna take a look at the data. So again, I mentioned in the demo, we're gonna have a selector that we can choose between data sets. So first we just, we're gonna use some widgets where it's they're Jupyter widgets that we use to help make it easier for everyone to follow along. So instead of writing,
well, it also makes it easier when you're working with your customers, right? Because rather, you know, if you have this set up prior to sitting down with somebody to have this causality discussion, you can just go in and say, hey, John, Marie, we're going to select this data here, and they're comfortable with that. Oftentimes they're not comfortable with the lines above, which we can hide, and we can just get right down to here.
Exactly. So now we got the student performance and the mystery data set. So you can go ahead and hit the make change, and we can view, sorry about this. So we're gonna have some issues here.
Of course we are.
Yeah.
It's a live lab. Why wouldn't we not have issues?
Okay. So let's go ahead and just, well, okay, we see this stuff. So it's some visualization issues here. So go back and we'll do the student, and instead of, we're just gonna skip this. So what we're gonna look at is our data here. Okay, so we're having some issues with our pandas in our Azure environment. So to make things just straightforward for us, I'm just going to take the library. So we did test this out, but of course, live events never work right.
It works right all the way up until you go live. And this is where one of you probably right now who's done this is, oh yeah, I see some problems. Here's what I'm going to do. You probably want to feed that into the messenger right away and say, this is the issue that somehow we discovered during a live demonstration.
So pandas, which is the main library from in Azure, is giving us difficulty. So that's a so why don't we go and just make sure.
So we're just going to pause for a second. We're going to see if we can troubleshoot this, because this is real life.
All right, so this is we're having issues definitely with our with pandas and Azure. So we can try to I can try to run this again, the cluster, but so far we're pandas is giving us a issue which is already preloaded into Azure. So I'm not sure why Azure is giving us its difficulty. See if we, let me just open up a new notebook here. Oh, and another thing we can test out too. Let's just make sure there's nothing wrong with our Jupyter Lab version of it. So let's just go in here. Yeah, it's still giving us issue there. Let me go ahead and import pandas. Okay, so for some reason, let's go and just, I'm going to test it here and I'm going to restart the kernel in here and just see if we can kick this off again.
All right, well, let's do that. And how long do you think that's going to take to restart everything?
So, okay, we're up and running. All right, so I suspect it was something to do with our install, but yeah.
This is real life, right? I mean, you know, when you're sitting down with a client, customer, your chief medical officer, chief marketing officer, and you're going through here, we're obviously doing this ahead of time, making sure things work out in our environment, but sometimes things don't work, right? And the question is do you give up or do you keep pushing through it? And we didn't, you know, and it was easy to push through it, right? We had enough information to say we knew what the problem was. And with a simple restart in this environment, we're back up and running again, right?
Yeah. Yeah. So I mentioned we said it would be good to do the kernel and restart. So what is most likely happening is that when we install these things, there were some issues with our libraries, and then so it would be a good thing to just hit the kernel and restart it. So we install the restart the kernel, clear out all the caches, and have our libraries back and running. So now everything is running as suspected. So again, let's start this over. We have now our data sets that we can view here. So you can just take a look and you see the data sets. We're going to take a look at the mystery data set later, but let's start with a student performance. So you can see here, now we have our data set, and you can see that we have 395 rows and 33 columns. So this is all the data that we have in here. And then where's my slider here? But anyway, I don't see the slider in this environment, so I can't move it over, but maybe I can do this.
Let's just keep down into our data engineering and get into the actual causality piece.
Yep. If we want to get more information about the student data set, we have that here. So we can look at all the attributes, and we can get the description of them. So for example, what is M or Medu? So we can go down here and then we can see, okay, that's the mother's education. Okay, well, that's good to know. Again, this is now we have a categorical values as well as numerical values. So let's go ahead and the first step we need to do is to make sure that we're going to remove any sensitive columns. So Dr. Jared, you mentioned this before.
So
let's go ahead and talk about this again.
Yeah, so as Arni's actually executing this phase here, here's some interesting things. Question we often ask, that's often asked of us is, how do we make sure that our models aren't biased? How do we know that the outcome isn't contingent on the sexual orientation of a person or its religious content or the color of their skin, right? And we're often asked to remove that data from the analysis. Well, and we do that because that has no impact on the decisions we make. But one of the things that we can do in terms of the process is by keeping those things in future analysis, by reincorporating them, we can begin to look at the causality aspects of it. Are they causal in that? So that you can begin to unambiguously answer the question. The role of sex in this area has no causal relationship to anything else, and we can show that through the diagram. For the purposes of today, we're gonna show you that if somebody says we're not going to include these, we're going to remove them from the analysis, and then we're going to move forward with it. But it's an important part of a conversation to have is what variables do you want to include in the analysis and not, because they could be causal, and then have that conversation. Let's keep going.
Yep, and so again, we're going to use this function here to perform some processing. So what we're doing here is we're going to we removed some columns in here, but we have some categorical values. We're going to make sure we convert them to numerical values. So that's what we've done here. So now we see the same data set, but just has been pre-processed to only contain numerical values, because that's what is necessary to run our model. So we can get some descriptive statistics on the data set, and you can view those here. You can see the count, the unique, and some other feature or other statistics.
Which are very underwhelming when you look at
yeah,
data like this. Like, you sit in front of your customer and go, yeah, let me walk through some of the descriptive statistics regarding this project. They're just going to look at you like you have a third eye, right? So now we're going to move into the causal structure.
So this is where the magic is happening. So we're going to use CausalNext to generate a structure based on our data set. And we're going to have to give this maybe up to a minute to run. And we're going to generate a structure that we can then visualize. So let's give this a
Yep, so while this is running in the background, I'm going to reinforce the key lessons that we're trying to learn in this process. We've worked with our chief knowledge officer to get the results of an initial study that they've conducted in the field regarding the efficacy of students that have learned online and students that have not learned online, right? That's the made up example here, but we have this now data. We brought that data in. We've taken a look at some of the variables in here. They sat down with us and they said, listen, we're really not interested in understanding or predicting based on any of the classic protected status lines. So we've removed those values out of that, right? Our goal now is to identify the causal drivers of those remaining sets of data, right? Assuming, of course, we're controlling for sex and race and things like that, which is a whole separate conversation in that space. And we loaded that data into CausalNext, and now we're going to take a look at the next things.
Yep. So I just take a copy of the structure. So because we're going to play with the structure, so that's why I just take a copy of the original, because this is the most time-consuming step of running it. So that's what we're going to do here. In here, I've just created a function which is going to use our eCharts library to make it easier for us to visualize it. And so let's go ahead and view the structure. So this visualization library has an kind of automatically, it tries to adjust the structure and balance it out. As you can see here, we're not seeing, like we just see that everything is
well, there's the problem.
Connected to everything. And
but that's completely clear, isn't it? I mean,
right.
That's the thing. That's the thing. What it's saying here is, if you actually kind of drive into this now, is it's saying these are the relationships we have. It's a very complex, interconnected, causally interconnected world here, right? For us to begin to think things as simple as study time alone has an impact is probably undervaluing the complexity of this problem, right? So if you click on one of those areas, just click on one of those items, you'll be able to, and zoom in a little bit, you'll be able to play with this data here and see the arrows coming into it, where they're interconnected, et cetera. You blow your screen up large and you can explore this area, but there's a little better way we can probably get some clarity around this right now.
Yeah, so I just wanted to throw this in here. So we're gonna do some, have some thresholding we're gonna have to play with, but I want to kind of show it as the model comes in without any thresholding. It's all connected. In addition, I also want to point out that showing a different types of visualization. So right now we are using eCharts, which can self-balance the structure, versus we have here a structure that does not balance it out. It just keeps it as it came from the structure.
Yeah, and before you move on to that, a couple things is you mentioned some filtering. One is we're going to weed out some of the less important, the less influential relationships next. That'll clear up some things. But this diagram here shows the relationships of relationships, right? As you dig into it, you see there are certain things that are clustered together that have an impact on other areas, and other things that are totally off the charts in terms of their relationship with anything else. So there's a couple different ways, again, Causality 101, that we can look at these maps that give value to us. We won't go into a lot of that today, just recognize that we can generate it here. Let's go ahead and filter some of these things.
Yeah, so we got here where we can remove edges that are not within a threshold. So we put it at 0.8, so let's go ahead and do that. If my shift is gonna ever work.
We're just filtering out all the least influential causal relationships, only focusing on the top ones here.
So why am I, my shift button just got Windows complained to mom. I was holding in shift, so it just Windows went bananas on me.
It's a demo.
Exactly.
It's a live lab. Oh, well, look at this. This is interesting.
This is very interesting.
Can you zoom in a little bit?
Yep.
So these are the important relationships. Well, first of all, zoom out a little bit. We see that there are, we have a topography here. Remember, this is a causal map now. What we're saying is, hey, Chief Learning Officer, these are the key drivers that are driving grades, G1, G2, G3, right? And there seems to be a structure here in the center. And then we have some outliers here that don't seem to be influential at all in this, but are part of this model. First thing to note is, your third semester grade is probably contingent on your second, if you zoom in a little bit here, right? Just zoom in a bit. There you go. And then go up a little bit. Upper right. Yep. That upper right. You see, yep. So that kind of is a validation, right? If you do well in grade 3 in your third term, you've probably done well in your second term, and you've probably done well in your first term. That should be like that makes sense to me. If that didn't show up, I would probably start to argue whether or not this was a good model. Then as we zoom around now, bring in, there we go. Now we start to take a look here at some very interesting factors, right? We see that there are some direct causal factors in your first term grades. But we also see an interesting pattern here to the upper left, where we see, what is that? What's the one box there? Up cursor up a little bit. I can't see it. So I'm trying to blow it up. No, upper left.
Oh, sorry.
Right there, that one. What's that one? No, down. This is the fun part of this. This is right up, right there. No, I'm not going to play this game. Upper right a little bit more. Keep going. Right. Nah, forget it. Anyways, we see this pattern here in the center where affecting grade 1, we see what we call a controlling Z piece of it. This is where I wish I had control in this space. Just go one box over, Arnie, on the G1. What is the to the left of G1? To the left of G1. That one. There you go. What is that? That's school supplemental.
Yep.
Right. So that's the school supplemental. That is the extra education that support that a student receives. And you would think in this particular case, well, gee, duh, students that get more supplemental education should do better in school. But you also see that there are some other influencers in here, right? So we get these very complex relationships, these things that could be confounders in this network. But here's where we are now. You're now showing the relationship between study time, supplemental schools. I can't read some of the other variables on the far right. Family support. All those variables have on your grade level 1. So now we can have a conversation that says things like supplemental support has a direct influence on it. If we take a look, what's the one? Go to G1 again real quick. This is the one I was looking for. G1, now go down to the left to the one, the heavy gray line. What is that one right there?
So this is the higher education.
Higher. Yeah, so here higher.
And want to get a higher education.
Right.
Because if we go back to our here, it is the high wants to take higher education.
Yeah, so go back down to this thing, and what's the one? So go back now, right there. Now, what's the one right to the right? Higher? Put your cursor over there. You go. What's that one?
Study time.
Study time. So this is a classic in causality and control for Z. Somebody would say, "Hey, boss, study time has a direct influence on G1." And you'd say, "Yeah, it does." But it just turns out there is a confounding factor that not only affects study time, but also affects your grade, and that's a desire. So this, I tell you what, this is the most impactful analysis you can do in this space, is to turn around and say, yeah, you know something study time is, but now we have to control for desire. When we build our models, we have to think about breaking that model apart, because you just can't lop everybody together. You get into these Simpson paradoxes and all sorts of other things, right? Where at this particular stage, we now know that the study time is also influenced by this desire to go to school or not, right? So you think about it. If I really want to go to school, I'm probably studying more. If I don't want to go to school, post-grade, I'm probably not studying more. That actually has a bigger impact on rather than saying study time or no study time. That, I'm telling you what, if your head didn't go purple and explode with that one, I'm not making sense. This is the COVID speaking, but that's so important here. That's what you just did with this analysis and sitting down. And now what we want to do is we want to continue this conversation over a series of meetings with folks to understand these relationships in deeper area. And then we're now going to go off and we're going to build a model. We're now going to sit down, now that we've identified the factors that are involved, our chief education officer is going to say, listen, it would be great if you can take those causal factors and build for me a predictive model that we can then optimize our student experience with. And that's what we're going to do right after this break, right? All right. So what else do we have in this section, Arnie?
Well, I just want to also point out again, so we got the structure here, and you mentioned, Jerry, that we have a thicker arrows, and that's to show which one are stronger and weaker relationship. And again, you've talked about it multiple times that wanting to seek higher education has a huge impact on your grade.
But it also has a confounding impact on your grade by the study time.
Right.
And that's where people would say to you, oh, if your kids just studied more, they would do better in school. Well, that's a true statement, but it's not a true causal statement. Yeah. It's a true, and because we have this confounder that we have to control for in this space, which is a really, really super important piece out of this. Do we have any, oh, we want to remove some subgraphs and do some mystery models.
So the subgraph is just to, so we have this structure here, but we have also some nodes out here, and that's what this step here is going to do. Again,
so while you do that,
my shift is still not working, so I'll have to do it kind of manually with a mouse. So again, now same structure, same everything. It's just I just removed all the extra nodes.
This is what you cut and paste. This is what you have the conversations with. Now you can sit down and actually have conversations around what programs do we need to do to influence a student's desire? What programs do we need to do to influence other areas as well? Now, with that said, this is where we would love to, this is where we would say, okay, let's go back and do this on another file. I'd love to see your faces on this one, but we have a mystery file, and we're just going to walk through that, and we're going to ask a question, what is this telling us? So this mystery file, we're not going to tell you what it is right now, but we're going to walk through the same process real quick, and we're going to go through the analysis quickly, and we're going to look at it. And I just want you to look at the results and tell me what you're thinking. So let's go ahead and do that real quick on the mystery file.
So let's go ahead and again, load our take a look at our mystery file. So we have, this is our mystery file. We have 31 feature, and then at the end, there's going to be a target, which is going to show us the, which is going to be a target with a binary classification. So let's take a look at this one and just run it.
Yeah, let's just get it in there and let's take a look and see what lessons we can learn from the mystery.
And by the way, this error message is because we are working from here, but inside the lab. So it's just complaining that I'm changing it on this side. So don't be alarmed. So again, we have some, we got to run the structure. It would take 30 seconds or so. And
wow. So this is the fun file that when we kick off projects that we remind all of our causality specialists about, right? And of course it comes back looking like that.
Well, that's a simple fix here. Well, I thought it would be a simple fix. Hold on, where's my keyboard? Okay, my keyboard just broke. Yeah.
All right, well, let's do this because we've reached the end of the time on here. Let me just say what this, and I'll have you guys run this on your own. It's a simple run, assuming of course you have a keyboard. What this file is this is random data. It's purely random, right? And one of the tests that we do for our causality specialists is have them look at a set of random data. There's no relationships to any of this. And when you actually look at this data and go through the same process you did before, lesson to be learned next time, have some graphics available in case things break, is that you would see a number of variables are not connected to any of the other variables on a display. And the lesson learned here is this: sometimes there aren't causal characteristics to the things you're looking at, right? And as much as we want there to be a causal relationship and we try to find one, there isn't. And this is a great process to figure out those causal versus non-causal things, right? Studying that kind of random data stuff tells you a lot about your process in that, right? So here's what we're going to do. It's the top of the hour. Here's where we've gone so far. We've gone through the circle of life, the 6 elements. We've talked about data science characteristics. We've actually walked you through breast cancer. And if you were following that, we found one of the first causal models that relates features and characteristics of breast cancer by diagnosis or biopsies to its outcomes. We've created a predictive model. We've actually brought you into a lab where you have access to the data both offline later on, where we've created a causal structure now for education, secondary schools, and we've seen the complex relationships that they have. We've done that. And unfortunately, we weren't able to show the stuff with the random stuff. We're just going to take 5 minutes till the top of the hour here, just quick 5-minute piece. Arni's going to get set up, and now we're going to take this model, this higher education model here, supplementary school education model, and we're actually going to go into the wizard, and you're going to build out a classifier for this model in the wizard again. And then we're going to then wrap up the day with some observations around optimization, right? So that's what we're going to do next. So we'll come back, we'll hang out here till top of the hour. Arni's going to switch us over. This is normally where if I were able to see your faces, I'd ask you questions and we'd hang out by the, go ahead, Arni, you can switch over to the wizard stuff and I'll just sort of, I'll run some conversations. This is normally, and this is, we got to learn this from the next one, right? For those that are hanging in there, I feel bad that I can't hear your voice, right? You know, and whether or not you guys are sticking hot pokers in your temple at this point and saying, oh my gosh, when will this ever end? Or, wow, I have so many questions that I want to dig into this particular area. I feel very isolated from this process. So we got to work on that process next. That's a lesson learned that we're going to take out of here is we have to have an ability to hear your voice. But I hope that you are seeing a few things for those that are still around the table. Again, this is me rambling talk, right? And my team knows that I do this quite a bit. While we're getting ready for the next section is, I hope you've come away with this concept of causality is being an important part of AI now. And it's an area that we call Causal AI. Matter of fact, if you do a Bing search on Causal AI, you'll find the Microsoft search algorithm will come back with some recent articles on the value it has because of the key thing that we talked about. Causal AI is the only way you can change the world. Everything else is just observing it. Now, you may want to observe the world, right? If you're a surfer, you just need to take advantage of a wave with a good surfboard. That's correlation, right? You don't need to cause the wave. You just need to take advantage of the wave. So there's power in good correlations. But if your goal is to help your customers, if your goal is to make the sick healthy, make the financially underprivileged more privileged, right? If your goal is to get people happier relationships or to help people with their education, get people who are looking for the right product to have the right product, right? If your goal is to change their world, not just observing it as a reporter does, then Causal AI is that way. And within this Microsoft ecosystem we have now, as flawed human beings as we are, and by the way, we've clearly demonstrated today that things often don't go as planned, we were still able to start changing the world with breast cancer and with higher education, right? By doing that causal analysis. Now, we also only did it with our Causal Next. We have a partner, which is Compellon. Again, send us feedback on areas you think we can improve on, have Jerry talk less, do more of this, right? Where we work with Compellon, and Compellon is an extremely powerful ecosystem that we do supplementary causal analysis and predictive modeling. And of course, you can't undervalue Bayesian labs, right? If you're doing any kind of real causal stuff, you're talking to the Stefans of the world and you have Bayesian labs in and you're doing all that heavy statistical breathing in that space, right? But as a data scientist that is working towards building better models, again, 3 minutes to go, 2 minutes to go before we come off of the break. If you're trying to build better models that are going to change the world, just not observe it, you want to start with that causal piece, take those causal inputs, have the conversations with the business, drive those into this next module that we're going to do, produce causally driven predictions. And what do we mean by that? That becomes a digital surrogate, all right? Digital surrogate that is capable of changing. Here's one example. So this is, again, as Arni's getting us all set up here, again, we're in break time. We're hanging around the virtual cooler. God, I wish I can hear your voices.
Yeah, I just want to, this is the model we did in the demo. I just want to show the results.
What do you get?
So we got, our model is really good.
Oh,
like
wow.
I said, the boosted decision tree is predicting this 100% on the training set.
I don't
and
think
then on
I don't think we've overtrained that model at all.
And then, yeah, so you can see, yes, we overfitted it because we missed 7 patients on the test set.
Yeah. Well, look at that. I mean, so now we actually have here's the thing. We have a great model, but it's also causally driven. So we can begin to ask questions around, if I change this parameter, it affects the malignancy determination this way. And then the next question is going to be, how do we change that parameter? What are the therapeutics and pharmaceuticals, what are the nutraceuticals, I should say, and pharmaceuticals that impact this characteristic of this malignancy determination? And then getting those people involved. Well, okay, here's what would do that. This particular pharmaceutical has this impact on the body, and that impact on the body would result in that change in those dimensions. And that would be a positive influence on whether or not that malignancy, whether that thing would then be classified as malignant or not. So we can actually look at this we can actually look at breast cancer from a different way, right? Our ability to now causally predict allows us to actually sit down with nutraceutical folks and pharmaceutical folks and ask the question, what things can you do that would impact these parameters? You are changing the world with that conversation. I'll give you one example, again, conversation, and then in a minute we'll get kicked off. We did a study with genomics around 295 women, again, breast cancer, mean time between relapse, right? Average mean time between relapse for breast cancer is about 10 years. You get treated, it's about 10 years later that you may or may not have a relapse. We looked at 290,000 genes, 290,000 genes, of which in the industry, most people think there are about 70 genes that are related to this area of relapse. We did that causal analysis, and what did we find? We found 3 genes that were causal to the mean time between relapse rate of women with breast cancer. So you went from 290,000 genes to 70, the industry, that was their study group, down to 3, which is causal. We can all sit around a table and talk about those 3 genes. We can bring a geneticist in and say, what does it mean for this gene to go from this condition to that condition? And we can have a conversation with a geneticist, a nutrologist, a pharmaceuticalist around what are the characteristics that we would need to put in place. What are the phenotypical expressions of a gene that have to be triggered either by pharmacy or nutrients that would cause this either genetic result or phenotypical body results in doing this, right? That is how you change the world. Right, in that. So let's continue on. Welcome back. I was just carrying on some conversations here. We were looking at the previous model. We now have that causal model for secondary education that we're going to then model up. We're going to say, okay, let's see if we can create a model that we can use to change the world on, right? And so now Arni's going to take back over. He's going to pop into our Visual Studio, and we're going to model that up, and then we're going to finish up the day with a conversation on optimization.
Yeah, I had to go into settings on my laptop and get my sticky fingers unstuck. But going back to finishing off our mystery data set. So we have that here. So just wanted to show you, that's kind of similar view we saw before.
Yep.
So we have all the features, and then we have the target here. But
let's do the filter real quick.
Yeah, so let's do the filter. Sorry, and let's plot it too. And what do we get?
What do we have here? We have a bunch of data that isn't related to each other, right? So again, that's the lesson that I was trying to point out before. Sometimes there is no relationship between data. And boy, I go back in the Navy days when we were studying the acoustic characteristics of submarine breech doors opening up, and thinking that we had solved the problem by modeling our environment using synthetic data. And as it turned out, our AI system actually learned our model and said everything that wasn't a model was actual bad guy stuff. This is the lesson that we learned. Sometimes random is random, right? And you have to be able to detect that. So anyways, that's a fun one. So I encourage you to actually take that data set, which is just random data, that's all it is, and analyze it during your process and see if you are seeing things that you shouldn't be seeing, right? And your process should be able to connect to this. So let's go back to our Visual Studio now and Continue.
And just want to highlight here that we're going to use these features here that from our model that we took out here.
Okay.
So the most relevant features we're going to use are these, and that's what we're going to model. So those are the most influential or causal features. So yeah, looking at our part B, we're going to go through our studio. We're going to upload the data set. So while I was kind of broken down, I went ahead on my other machine and I just uploaded the data set. So we can take a look at that here. So we have that already in place. So let's go back to the designer, and here's our demo demo model that we created. We already looked at the results. So let's go ahead now and create a new model. So we have to select the compute again. Now we got two data sets in here, breast cancer and the student data set. We load it in here. Let's take a look at it. So again, we have the full data set here. And you can take a look at all those variables. And if you want to take a look individually, you can select them, and then it will give us some descriptive statistics on each one. The next step that we need to do is to select the columns we want, just like what we did before. So that should be under the, well, let's just find it, it's easier. So let's go and select columns in the data set, connected, and list out these few ones we need. So I had a list here, and we're going to do the well, first let's make sure we got the target. So the G1, we need to find the school, and sorry, I'm listing the wrong here. These are the ones we want to remove. So G1, we wanted the higher education was definitely a strong one. Study time, we talked about that one before. The school support, the failures, P status, address, how close you are, and family support. All right, so now that we got those selected, so we can go ahead and run it if you're not, but what is gonna be more, so we can run this right now. If you take a look at the data again, let's go see this again. There's one thing we need to address here, is that we have these columns here. We're gonna do the G1, the grades for your semester one, and they're in not in binary. So we're not doing a classification if we treat the columns like this. But what's probably more interesting to view is to look at this as classification. So to simplify it, we need to convert this all these variables or all these numbers into just a single or a binary classification. So we want to take a grade from 0 to 10 as being a fail, and then 10 above is a pass. So let's go ahead and do that. So Microsoft Azure ML makes it easy to bin this. So let's go ahead and find our binning here. So group data into bins. So, and we want to make our custom edges. So we can do 0, 10, 20. And we're going to do this on our G1.
And this is where you'd have that conversation with your customer, right? The chief education officer, and the education may say, you know what, maybe pass and fail is a little bit too hard. Maybe it's fail, marginally needs help, and then passes, right? But you can have those conversations at this level, right? For purpose of today, it's pass or fail.
And then so we get that in here. And let's go ahead and split the data. So again, now we want to do it again, splitting the data 75, 20%. And let's go in model. And then we need to make sure we got a model. So again, let's just pick our good model. It was pretty good last time, so we'll just select it again and see how well we do on this data set. We've got to make sure we got our target selected. And then we need to score everything. And then again, just to reiterate what we're doing is that we are going to score, we're going to split the data 75% into training, 25% into tests. We're going to train the model on the 75% of the population. We're going to train it using this model. We need to score it. So once it's trained, we're going to give it the prediction with a probability, and that goes into this scoring module. And then to make things easy for us, we're just going to add this evaluation module where it's already pre-plotted for us the results, and we can compare the test and the training. So again, this is now complete, and we have to submit this. So we're going to create a new one, and this is going to be the student one. So while this is running, we can, there's multiple other things we could do. We could
you could hyper train this thing, can't you?
Right, yeah. So what we could do is, instead of, so in this section here, we can swap out and instead of just a single parameter in the training, so we just use the model itself, the algorithm, the boosted decision tree has multiple tuning parameters, and we just use the default one.
Right. And by the
way, in most cases, this was what has worked. But what we need to do is to really to get the most out of your model. The best way is to take the model, give it a range of parameters, and that's what this hyperparameter tuning is, what we were talking about. And so we can bring this in here, and we can maybe show you guys if we have time once this is finished running. So that would go through a sweep of all these different parameters, and it give us multiple results. And then we would pick the model that has the best results.
And that's a general characteristics of all learning models, right? So remember our three categories. We have data science, which is making study sense out of the data. Our primary tool for that is that causality work that we did, because we want to change the world, not just observe it, right? Now that we're in machine learning, human beings are notoriously bad at configuring things, right? So we start with a very first pass that we're doing here with standardized ML operations, but we can also tune that, and that's where AI can help us out a lot, which is to go through using, think of it as Monte Carlo characteristics to randomly walk through the configuration space, and then we make a determination which of those is optimal for us, and then set those up as our parameter. Sometimes you get better, sometimes you don't, right? And using things like evolutionary computing, you can actually evolve your way into a better place. That's a whole separate issue on optimization. But this is, again, I go back to, where are you at this stage, right? You determine the causal characteristics of secondary education impact. And now you've visually created one of your first models, sitting in front with your partner here, and going through and answering the question, can we can we predict whether somebody's going to pass or fail based upon these factors that we're going to, if we can do that with any degree of accuracy. And by the way, this is a good plug for how do you measure success, right? You have 3 measures. You have what would random do, right? If we just randomly did these things, how good would the outcome be? The second is, what does the current process show us, right? In our current educational process, in this case, the secondary, if we create policy, what does that policy show us? Well, we have field data for that. We hope that policy does a better job than random, right? That's what you always want to make sure. What we're doing now is better than random. I can tell you stories where that was not the case, where customers were actually worse than random, worse than a coin flip. And then lastly, through this process that we're doing here, causal-based AI, where we're now building a digital surrogate, which is a predictive model based on causal inputs, we want to be able to say, look, we can optimize our desire to improve education beyond your current policies by doing these things. Because now that we know we have optimal inputs, we can then ask the question, what programs need to be put in place to achieve the inputs that are going to maximize this? And that's what we're going to talk about in the last section here. That's where you've gotten. And I hope as you sit and think about this as a data scientist, machine learning specialist, AI specialist, that you think, well, I don't have conversations like that with my business people. And I'd hope you think, I want to have conversations like that with my business people. And because I believe, having worked in this field for eons, that these are the conversations that your company wants you to have with your business people. Because this is when you're now changing the world again, right? We're just not throwing data out there and fancy statistics. We can, by the way, we can spend forever on descriptive analysis and diagnostic techniques. Those are important. But the most important thing is getting us to a causal-based predictive model so we can begin to ascertain what programs do we put in place? What new products do we offer? What new services do we have there? How do we change human behavior so that those inputs change the way that our model needs them to change? Now you are helping us change the world. As we're waiting for this spinning, rotating world cranking through our data, wonderful space. And it's very visual, right? And as a data scientist, this is my favorite space. You know, I do not like to think of, listen, there a lot of guys out there are going, I'm a hardcore data scientist, I work in Python. I appreciate that, right? But at the end of the day, I want to get to as quickly as possible, how do I change the world? And I want to have a partner sitting next to me looking at that as well, going, hey, by the way, Arni, why did you use 75%? You know what, I've always heard that. Why 75-25? Right? We can have that conversation. We can sit there and say, well, I tell you what, let's just try 50-50 right now, if you think, and let's just see what the impact would have. And pretty soon you're educating on that, right? And Arni, is this the best model we got out of here? Well, you know, it's my guess. Why don't we hyper tune this thing? Why don't we let AI do that for us, right? And we do that work as well in this space. And oh, by the way, Arni, you know, I know we did this one causal model, but I'd really like to know, does sex have an impact? Do boys do better in secondary education or girls? How's that for a taboo conversation? Now, could you control for that? Here would be a great thing to find out, that you actually ran the causality model, which I encourage you to do offline, and find out whether or not girls or boys are better treated in secondary outcomes by just the pure nature of their sex. And if they are, the next question is what can we do to unmake that happen? That's the conversation you can now have with that causal model and the predictor. You can start to say, okay, well, you know what? We have bias here. There are some biases built into the system. We now know that a certain percentage of, in this case, boys happen to do better than girls. It is an influencing factor, as it turns out. What programs can we put in place? And, you know, we have those programs that are out there that'll help both economically disadvantaged, but also gender disadvantaged individuals in this process. And now, but here's the important thing. We have quantitative data now. We have the causal model. You know, Judea Pearl would bow at your feet, right? Would go, oh my goodness, causality in practice to drive predictions, to drive outcomes. That is what you want to do. And we're still waiting for this stuff to come.
Yeah, and while we're waiting on this to run, maybe it's a good time to show that you can also run AutoML. But what this does not do, which is what is most important to us, is that you want to be able to select the causal features.
Yeah.
But let's say you filter out your data set and you only have, sorry, my Alexa here is interrupting. So you only have the data set with the features that you want. So what we can do with AutoML is that instead of, you don't know which model is the best, and then you can go and you can select the data set you want to work on. And we can just call this AutoML. And then we select the diagnosis as being target. We have our compute. And that is, hold on, I should have created a new one. And so it's going to recognize from the data set, we're doing a classification because we selected target as being benign or malignant. And so this is all there is to the AutoML. You hit finish and it's going to set it up and it's going to start running. So now we have our designer running here while we're having the AutoML set up. But what's going to be interesting once we get this thing running, that we can see how each model kind of get ranked based on their performance, and we see the start to see which models are going to be the best, and then we can just run this for hours till we get the best model. But we of course recommend that you work in this area here, because then you have more control over your features to make sure you got your causal features running. But if you're you got a new data, you want to quickly just get some prediction on it, you could use the AutoML, which Microsoft has.
So let's do this. Let me wrap up the last section. You monitor this when it's done. Me.
That sounds good.
And then what we'll do out of that is we'll switch back over and see the results. But the results, where did I go? I lost you. Of course, again, I failed the test by not getting my picture in here. There we go. And then this is my desktop. There we go. All right. So we're baking out that model, but we're going to come out with a digital surrogate, right? Causally based model. So what do we do with this? What do we do with these models? Well, this is a deep conversation around optimization. Remember, we went from data, the debris of human activity, into causality, into a digital surrogate, a causally driven predictive model, and now we're going to focus on the outcome. And so for the purpose of today's conversation, it's just a conversation, right? Because this is a very rich field and it's one of the least applied right now. But if you think about this last phase down here, this step 4, right? Within this world, what we want to do is prescribe solutions now that maximize the business benefit that we have, right? In our case, how do we get more kids get into second? How do we improve the grades of kids? Or in the breast cancer case, what pharmaceuticals, nutraceuticals can we apply that reduces that influences cell growth that then has an impact on the malignancy characteristics, right? So we're trying to go through that complex search space, and it is a complex search space, right? So we have 2 kinds of evidences that are coming into our digital space. We have the causal pieces that we walk through nauseously, again, walking through that. What is causal, what's causal, what's causal, that built our digital surrogate. And then we have the correlation features that we took away. Within that causal space, our goal now is to answer the simple question, under what combinations of causal inputs will produce my best results? And this is a multi-dimensional optimization problem, right? Simple 2D case over here on the side, 3D case here on the side, 2 dimensions and an outcome. And we've seen these maps before, right? But you can have everything from the benefit to the revenue side of the house and the time, right? How can I increase how can I improve grades in the shortest time with the least cost? That's a complex problem, especially we had 7 inputs to our model. Right, 7 inputs, and if those inputs are changing 2 at a time, you have 2 to the 7th. That's a big number. 2 to the 7th minus 1 search space. That's a large search space to move through. So how do we search through that space? There's a number of different ways to search through that space. One of the easiest that we use quite a bit because it's quick and effective is stochastic methods, right? Your classic Monte Carlo, right? You take your inputs and you randomly sample them as a function of their distribution characteristics. How do the inputs vary? Normally distribution, log, binary, etc. And then you do that over a large sampling of opportunities, and then you look at the output, and then you can map that space out. That you can do very, very quickly, especially in Microsoft Azure, right? The lab environment. You can set up that Monte Carlo experiment and very, very quickly numerically begin to say, hey, you know what? If we want to get grades the maximum at G1, this is the conditions in which we need to set up, and then we can have those conversations. But there are some more interesting ways, which are learnable ways, which actually is where my PhD is in, which is population methods, right? This is your classic evolutionary computing space, right? And basically, it's a functional quantum computer. How can we actually in Monte Carlo basically it shares no benefits, right? You just go through the space and you find what you find. In population-based, what you're doing is you're using things like genetic algorithms to encode various characteristics and look for the population to converge around the smartest samples that which become the next generation population. Very powerful technique, solves a lot of complex problems. And actually, compared to Monte Carlo will only tell you of the characteristics you have, what is the best. Evolutionary computing will help you discover new characteristics based on suboptimal characteristics. That's very, very powerful technique. Then, of course, you got constraint-based optimization, linear multiple objective stuff, surrogate modeling, which is what we're doing here in a way, and then optimization under uncertainty. How do we deal with the impact that noise has in this space, right? So this was just a short observation centered around first that data is the debris of human activity, bringing that in, engineering that engineering record, single observation, right? Being able then to figure out what's causal, creating that digital surrogate. Now, what do we do with that surrogate, right? Because that is where we're driving. With the optimal inputs, the causal inputs for the conditions that you want to achieve, you can now sit down and do what? You can go to sales, marketing, operations, whatever it happens to be, that can then help you identify programs that create the conditions in which those inputs are achieved. Put those programs in place, sit back, wait for those things to take effect, collect new data, wash, rinse, and repeat, right? That's what we call the cycle of life, right? Once you implement those programs, once you change characteristics in terms of supplemental support, or you apply therapeutics to your patients or nutraceuticals to your patients, you then sit back and wait the 1 day, 1 week, 1 month for new data to come in, and you wash, rinse, and repeat. If you do that process through systems engineering, you will bend your business curve. If you apply, and I want to be very, very clear on that, if you take this closed loop process, step 1 through 6, and apply it, your business will change. There's no way it can't change, because it's a negative feedback loop. And that is, no matter, even if you make a mistake and you implement the wrong procedures, of course, we don't want to implement wrong procedures when it comes to human life. Well, let's just say you made the wrong product design choice that was designed around optimizing your revenue. It will self-correct in the feedback you get from the data and the causality analysis and the digital surrogate models you get. It may take you an extra period of time. Nyquist theory, right? Nyquist theory says sample at twice the rate that you want to make decisions. If your goal is to make great monthly revenue decisions, you want to at least do it. You want to run this process twice a month. If you want to make good revenue decisions every week, you want to run it at least twice a week. That's that's Nyquist theory to information. That you cannot not change your business. How's that for a double negative, right? You will change your business. And so we can actually change the world not observing it through this process. And it's a combination of what we do in terms of our data science behaviors, right? Causal-based AI, and also the Microsoft ecosystem that allows us to do that. Did we get an answer yet on that model, Arni?
It is almost done.
All right.
Last step.
I'll continue on here as we go, and I'll wrap it up with some of our next step stuff. It's in the bottom, because we're at the bottom of the hour here. If it is almost done, like you think in terms of seconds or so, before we go on to where do we go from here?
Well, I could just, we could look at the score and we can take a look at that if you're interested in. But no, let's get.
Yeah, I think we're okay. We'll see where we are at the end, and if there's anything wrapping up. I'd like to, finish up the things that we're doing here, and then let the people. This is where I think one of the things where our lessons learned real quick is we do need to get a venue for which people can raise their hands and provide us feedback. All right, so where do we go from here in this process? So we walk through how we see this world working, that 6 steps. I'd encourage you to really think through that, right? That was our whole goal, is to give that sort of pass over to you our perspective on Causal AI by both showing you a demo and then setting up an environment where you could, if you choose to do it, you can put your fingers on the keyboard and do this work yourself. So you have all the tools to do steps 1 through 3, and then talk about number 4, right? And then in which case you go off and implement it and then collect more data in the field. We would like to hear back from you, right? This is a first of many of these sessions we're going to have that is a part of an ongoing conversation. Our goal is to somehow figure out, the next step is to get you involved in the conversation so that we can have we can have a conversation, because right now it's not a conversation. So that's the thing. So if you can send us via email to the email that we provided, your feedback. Do you want to get a restraining order against me? Keep me from talking from now on? Do you think there are certain elements that are interesting in there that we should expand upon? Do you think there are areas that we can shorten up? I'm certainly saying that we need a feedback mechanism. That did not work out for us today. We want to hear from you, right? So that's feedback. Feed forward is my role in life is to help people, right? For those that have stuck out the day here, if you send me an email to jerry.smith@agilethought.com, Jerry, Jerry, .smith, S-M-I-T-H, @agilethought.com. If you send me an email saying, I'd love to talk to you about my problem, Arni and I will get on a call. He and I, we'll sit down, we'll just talk about what you're doing, right? What are you up to? What's your problem space? You know how we're going to walk with this, right? What's your business problem? Have you thought about causality in this space? Do you have the data? Who's your business partner? We'll just talk about the problem, right? We'll give you some thoughts in there, right? Maybe even set up an experiment where we can take some of your data yourself and actually walk through and figure out, oh, look at this, man. Look at let's just say you're in the transportation industry and you're trying to figure out how do we maximize our revenue and minimize the time people have to stay on the road, operationally maximize the capital assets that we have, trucks and trailers, minimize fuel costs, and make sure that spoilage doesn't occur for our perishable products. How cool a project would that be, right? If you're in the transportation industry, that's the ultimate optimization problem. Where do we start? Do you have data? What's causal, right? What's causal? Let's work on this. And maybe it's causal neck, maybe it's Compella, maybe we pop into Basel lab, depends on the complexity, but let's get that causal model out there so we can then start answering the question, if my goal as a CEO or a VP of operations is to maximize our revenue, what are the variables I can control in the transportation role, right? If you're a company like Walmart, I study Walmart a lot. I think they're an awesome company in many different aspects because they stretch our ability to deliver. You're worried about spoilage, right? You got products that are sitting on the shelf of a store on one block, and 10 miles away, you got them not even on the shelf in another. And so the question is how do you deal with spoilage and shortages and oversupply and missing opportunities? That is a causal study, right? So in that case, so we would like to help you. You send me an email, say, hey, listen, love to talk with you. I'll send you a link to my calendar, and you pick a time where you want to talk, and Arni and I will talk to you. It's a non-sales call. What I'm trying to say, it's a non-sales call. It's just guys like us and gals like us, sitting around talking about what you do, why you do it, and where you think some of this can help. And if you can walk away and be better at it, I feel like I've done my job. So we'll put up a 45-minute conversation. The next thing I'd like to talk about is we do have some upcoming events, right? which is always good to have the weather station tell you that you're going to have a impending weather event right in the middle of your exercise. So back to here. That was the emergency alert going off saying there's a weather event happening. We are having some additional events coming up. This is the first in a series of AN a day. Our next AN a day is not just a repeat of this, and you're probably saying, thank you. Please don't make it a repeat of this. Make it better than this, right? So we will do that. But we're also adding content to it, getting into the optimization stuff, right? Adding new subject areas, right? I don't know how we want to address it yet, but we have 3 to 4 weeks to do it. So please think about, if you were going to attend that next event, what would you want to see that was different than today, right? The other thing coming up is analytics in a day, and that's in March, right? We're having 2 sessions on analytics. We didn't talk about that today, but analytics are an important part of that engineering process, right? We have the layers at the bottom, data engineering and analytics, that piece in there. We have to know what we have in order to be good stewards of the insights that we did today. And there are some interesting aspects, things like the intelligence of your data, right? If you take causality and apply it to your data, right? Think about this. Here's a thought exercise real quick. This is what we're going to cover in the March timeframes. Let's just say you have 100% of your data, and you actually look at it from a causal perspective, and you look at it from the classic, what drives revenue, what drives profit, and what drives customer satisfaction, right? 3 classic dimensions of a business. You ask yourself, how much of my data is causal to revenue, profit, customer sat? If we did that analysis and we came back with the random diagram that showed that there's nothing driving that, do you think somebody in business would go, what the heck's going on? We are not in control? You think that would be an important conversation? Oh yeah, that's always fun to have with your chief operating officer, to say that we just invested $25 million in our data, our MDM process, engineering our data, and it turns out none of it is causal to our business. On the other side of the house, if you do that analysis and come back and find out that 80, 20, 80, 90, 100% of your data is driving your business, what you're saying is we got to keep doing more of this. It's in that middle area where you're not quite getting the results, the predictive characteristics of your forecast aren't right, you're struggling, and you're saying, do we have the right data? Do we need to augment it with other data out there? This is using causality in that process can lead to those conversations to say, yeah, you know, not only do we need it, we can quantify it for you. For this particular business unit, less than 10% of the data is driving their insights. For this other unit, we got 90%. We got to focus on what new data elements need to be brought into place. That's analytics in a day. That gets us to that spot for the CIO to be able to sit there and say, as an effective steward of your money, I got to tell you, we're over and under investing in our respective business units in this area, and actually have that meaningful conversation. Today, CIOs typically don't have that ability to have that. We're going to have that conversation, okay? Lastly, we have a fun event coming up. It's called Accelerate, right? It's really designed around, you know, improving your digital velocity for the organization. This is the first for us. It's in February. We're encouraging you to attend. We have internal speakers and external speakers. You didn't hear me say this, but given that we have some level of conversation going on here, I'm not one to go to a lot of conferences out there, because some of the conferences that I've seen in the past are just marketing events, and I hate marketing events. If I want to know about somebody's product, I'll go online and look at it. I don't need you to sit there and tell me forever what your product looks like. But we've got some speakers here. When I actually had a pre-event, just because I don't know some of them, and I've heard them in the past, and we sat down and had a conversation. It was 2.5 hours later, we finally had to hang up. They're just brilliant people. I've got to tell you, I am going to listen to this event just because some of these people are just amazing folks out there. You'll hear some fresh minds, some fresh abilities. You'll hear people doing things, talking about the problems that we're having today in this world of transformation, right? Because our goal, I'm just a small component. I'm an insights component, right? Our goal is to transform the organization as an entity. That's our goal, right? To do better tomorrow than what we're doing today, and do that systematically and using the tools we have, right? Digits, right? You and I don't dig mines. for our job. Our job is to manage an organization which is fundamentally digital. So this digital transformation, how do we make you better tomorrow, today, by using information from yesterday, right? That transformative process. You will hear, for some people, you hear idea scale, you'll blow your mind to hear his conversation, right? That'll be fun in that space. At the same time, you'll get a chance to hear from people like myself and my boss and other folks in here. Arni will be on there, Jose will be on there talking about analytics and stuff like that. You'll hear from a few of us as well, set up in the area of panels and speakerships. It's a great half a day, right? So I'd encourage you to sign up for it, get involved with it, take a look at the speakers in there, get on LinkedIn, take a look at who they are, start to think about, what kind of questions would you want to ask them, make that an important, rich time. This is not a marketing event. This is an actual, again, let's change the world event, right? And let's change the world by getting people like us together and having the right conversations we need to have in that space. Okay. So that's it for today. Do you want to just real quickly show the results of the model? I'll just say goodbye to everybody and we'll go from there.
Yep. I would like
just
to.
Real quick, so we have that. And then I'll just wrap up and say goodbye and give you guys this opportunity again once more. So what do we have on this final model?
So let me go ahead. I gotta add the content, get my picture in there.
Don't worry about that right now. They like seeing me.
All right. So let's see. So here are the results from our student performance model. So let's get that up and running. So as you can see on the RC curve, we're overfitting probably. And you can see the prediction model on the evaluation set is not very good. But what we see here is that we're predicting. Here's the confusion matrix. This shows us though number 1 is the people or students that fail, and then number 2 is the students that pass, have a passing grade. So you can see we're missing quite a few students, and we're not predicting them well enough. But that's just what data science is about. We might have causal feature, but we might not have a good model, or we might have a good enough population, or we might need more data. So this is part of the research and part of the exercise.
Yeah, you know what? That is the most profound thing that I think we've talked about all day long, right? So here, a lot of people would go, oh, woe me, my model sucks, right? I can't do anything with this. Not really. You already know the causal direction, right? Now, the next question is how do we improve those bad results? Now we start digging into those bad results, or we start asking the question, is it a modeling issue? Or are we actually lacking the right kind of data? And if we are, we can set programs up. We can go collect more data now, right? We can augment that data. And how can we do that? We can generate synthetic data to test the idea. Synthetic data improved it. Now let's go and spend money on another field results that collects the real data, right? That's where you guys are going with this stuff now, right? Out of this process.
Yep. And since we talked about the hyperparameter tuning, we can set that off. So you would hook it up here, select the column we need. Then we would set up our parameter range. So we'll just use the default. But then, so the hyperparameter tuning is, so we have several ways to do the hyperparameter tuning. So we can do random sweeps and put in the number. So what we're telling the program to, all right, we have these parameters inside the algorithm or in this module, and we don't know which one is going to be the optimum for this data set. So we tell the algorithm or the module to, let's do 5 random sweeps of randomly selecting these parameters and then run them and then give me the results for all of them. And then so this module would run and it would randomly select from the number of leaves samples, leaves, and so forth. And then we would get out. We can look at compare all the results and pick the best tuning parameters, and then we can just use the best model and see the results and so forth, just like we did with the training model.
Yep. Classic Monte Carlo.
Yep. Then also I want to just briefly show you guys, we set off the AutoML. So this can be running, and we ran this with our breast cancer data set, and we already got results that were 99% accurate. But then you can see what is going on here is that AutoML is going through popular machine learning algorithms, and it's just trying them out. And you can see them, they have a repeated thing here. So here you can see the random forest showing up at least 3 times, and it's running the same data, but with different parameters. So the AutoML is doing hyperparameter tuning. It is running different models, but and this is kind of like the first step into making things automatic. But again, yeah.
I'm going to put a little plug in for AutoML at Microsoft. Back in the day, we had a chance to compare Microsoft's with IBM's and a bunch of other folks out there, AWS's, et cetera, and compared to other techniques like evolutionary computing, right? No matter what you do, evolutionary computing will always beat you by definition because it evolves and learns, right? But within the AutoML generators, Microsoft is one of the best out there, right? And so as a go-to tool that enables you to quickly figure out what models I should be looking at, it gets you there quickly. The question you have to ask yourself is once it identifies something that is more meaningful than the other, is what is it telling me about my subject? When it does a random forest compared to another, linear programming model, what is that telling me that I should be thinking about when it comes to the way I should view my subject? That's the most important thing. It isn't the model that's important. It's what it's telling you about your subject that you can then have your conversations on. Right? So let's do this. Let's finish up. I'm just going to take over. I'm going to put one last screen up here. I'm going to say goodbye, and then we're going to call it quits for the day. Okay. Let me just bring this up here. Bring this over. Just share this again, and share that, and then send, there we go, this guy. Share that. There we go. And of course, I'm always wonderfully challenged with having to do this thing twice. Send live, there we go. So it's been a pleasure hosting all of you today with this, with our first of an event, right? Where we covered a lot of subjects. I won't cover them again. This is what I want to leave you with in this picture here, right? This is the cycle of life. If you can get your engineering, if you can get your AI into this picture, you will change the world. We covered with our Microsoft partner, we covered with you the benefits of doing this work within that Microsoft space, right? And I can tell you from a data scientist perspective, it's one of my best environments because I don't think about this stuff. We do what we did today. And rare exceptions, you're going to get the errors and stuff like that. But you get smart people like Arni hanging around you. You eventually solve them, but you're back on task, which is let's solve the business problem, right? And that is something that we do together very well when it comes to when you can leverage tools like the Visual Studio. You solve the business problem. You're not worried about the other stuff. We also learned that if you can get that causal model out and build your predictors, you are now in a position to change the world, right? You optimize. We talked about things like stochastic modeling and linear programming, evolutionary computing as ways to do that. I'm hoping to cover that on the future episode. So I hope you found value in that. And I hope you sit back and think, I feel good about some of the knowledge I have. And I hope you take me up on my offer, right? If you're listening right now, and you're trying to figure out what your next step is besides signing up for Accelerate, right? Or signing up for another future AI in a day where we're going to continue the conversation, hopefully more of a conversation. I hope you actually take me up and send me an email, Jerry, Jerry.Smith@AgileThought.com. And if all you want to do is talk about, provide us feedback over there, send me an email. I'll talk. If you want to talk about you, again, feed forward. We'd love to get feed forward stuff. right? Our goal is to help you, right? That's my only purpose in life, is to help people like you, right? And I really appreciate you being here and spending the day with us. Again, I think in terms of, I think we're better than serial number 1 on Elon Musk's Starship. We didn't actually blow up on the pad. I think we got a few, I think maybe we got 10, 20,000 feet up before we blew up, and we recovered some of the parts. So there's some science we can learn from this. But I hope you join us for next time down the road here in the next few weeks for our next Starship launch to see how far up we get on that one, and we keep making this journey together. Until then, this is Arni and Dr. Jerry saying thank you very much for attending, and we look forward to seeing you in the future. Bye-bye.